hide the belt pack, transmitter.
Can I put it in the pocket?
You can.
Okay.
Check on you. Say hello, hello.
Hello, hello. 1, 2, 3. Testing. Hello, hello.
How's your conference going?
Quick sound check on you.
Hello, hello. 1, 2, 3. 1, 2, 3.
Oh, you know what we forgot to do? Wait, is it power? Try again.
He'll get you
1, 2,
next.
3. 1, 2, 1, 2, 3. 1, 2, 3. Evals.
Do you want a handheld or a loud? Put mic.
Handheld is good actually.
Okay, cool. Okay, he wants to. When you're ready, just go, Mark. Yeah. Just remember the whole. Get comfortable and like put it to the side. Like we can't.
Yeah, can't take off.
Let's sound check you again.
1, 2, 1, 2, 3. Look at your data. Look at your data.
So Omar, that's what your screen looks like.
Yeah, it's great.
Yeah. I'm gonna put this back up.
Yeah, great to meet you, Rafael.
yourself?
Big fan of DSPy.
Yeah, I think I've come across your Twitter.
Yeah. I tried to do it the same in TypeScript and failed.
So now that I have a good portion of the speakers, I have something funny here. I wonder if you're all okay with it, or we don't have to do it, but I asked the AI to give us the intros.
Mm-hmm.
Sure.
And so one of the funny things I asked it to do is tell me the pronunciation for the name. So I'd be curious which AI model does better. So it'll also be a way that I can kind of like interact with the audience. So like, all right, pick the AI model that you want to try to make the thing.
So funny.
Is that okay with everybody? Yeah?
Sounds good.
All right, cool. I don't know if I'll have a chance to connect it, but I can always just use it and like just say it out loud. So that's cool.
For sure.
All right, cool. And no guarantees it did a good job. So.
Yeah, I think that's the point, yeah.
And it probably hallucinated, or I might have been me entry.
Want to do another check?
So feel free to like call that out. That okay, that thing was wrong about this.
Hello.
Like for
Aren't you
example, let's try Omar real quick.
Where's your mic?
Plot 4.
Right here. It's invisible. Invisible, bro.
Your MIT professor.
Incoming, yeah.
Cool. Nice. There you go. So I don't know if it used the web or what other things to like.
Maybe I think we submitted bios.
Yeah, I
Maybe
included
some
I included whatever you provided.
Yeah.
And the thing.
That's cheating.
I know. I'll give it enough context, right? But some of them.
You know what? I want to turn your belt pack off until it's your presentation.
Okay.
Because we have limited use of radio frequencies.
Okay.
We need
Sure.
to give Omar a handheld. No, yours is fine.
Mine is good.
Yeah,
Should I twist it or?
I'll get it.
Stress?
Here you
Well,
go.
it's kind of like
Reconnect.
free talk energy.
Yeah. You've done a lot of these, I bet.
Huh?
Have you done a lot of these?
I haven't done a lot of those, but it's been a while.
I didn't know you worked at Databricks. Is that recent?
I've been there for a year.
Yeah? I might have just missed it.
We're using the
They
same.
have a nice DSPy team there.
Yeah? Cool. Nice.
Well, it won't just turn off.
I'll bring it to you. Then,
Yeah. Okay.
yeah, if you don't mind.
Okay. And you're first, right?
Yep.
And you want Check.
And then mine is always on.
Do you want me to head back or do I stay or? Yes, it's still.
They want the AM session.
And I'll go up there.
And the cans there are the water. Yep. Maybe don't. There's some cans there. I think that's the water.
It's
Super stressful, to be honest. It's all good. Just be yourself.
I think it's for this.
Ignore the crowd.
That usually ends up badly.
Look at the last row, you know? That makes it look like you're looking at everyone.
Oh yeah.
I predict a lot.
maybe we contradict each other. That would be interesting.
That would be even more interesting. Well, he's gonna contradict us for sure if you.
Yeah.
Ours are gonna be pretty complementary, I think, because ours are like, okay, we did a lot of unit tests for like evals, and then we regretted it, and then yours came after, like evals are not unit tests, duh. So they complement each other.
You guys don't team up, or you still do, you just don't treat them?
Yeah, we just do a bunch of different types of evals now. We do more like trajectory, full conversation evals and stuff like that. Yeah.
That's what we.
Oh yeah.
Yeah.
Yeah. 18 people watching.
18 people, bro. We're famous.
Wow.
Dan, I can hear you before.
Test, test, test.
Omar said there's some recognition.
Hello, hello, test, test.
Yeah, I can hear him.
Test, test. Hello. Hello, hello.
Talk to me. How was your flight?
Good, good flight. Yeah, very long.
Good. Can you talk to me?
Hello, hello. 1, 2, 3. What did you say there?
Does, oh, I actually live in Spain now, so it's like a very brutal flight.
Oh, I'll turn it, just bring it to me.
Okay.
Like 12 hours.
Damn.
Yep, yep.
Yeah, I've flown to
That's
Europe,
brutal.
California before.
Yeah, it's rough. It's rough.
Well, originally from New York, so it's a much shorter flight. So I was like, because I want to go to France, I was going to go in April, but anyway, I'm probably going to go in September. I was like, okay, so I'm going to go to New York and stay a couple days.
Yeah, that's a good move. Good move. Yeah, yeah.
The shortest way from the United States to Europe is New York to Lisbon.
Yeah, indeed. Yeah.
You're back on.
No. I guess pretty much
I thought it's in
more or less the
Dublin.
same.
It's gonna be
Yeah.
shorter to New York.
Maybe slightly shorter. Maybe they're
Dublin, I think,
better
is really
flights.
far north.
Yeah.
Everything in Europe is far
Yeah.
north. This is one because of the ocean.
Yeah.
Hmm.
For the same reason that California is cold, even though the sun is strong.
Hmm.
Yeah, because the Arctic current from Alaska and all that.
Totally.
I learned that. Shit. Why the water so cold?
Yeah.
I'm used to SoCal and Florida. So what's up? Go to the 5-5 wetsuit.
They told you the dream, but it was it was a lie.
I was like, oh, this is why in movies, when they show you in Northern California, people always have on a hoodie
Makes sense.
and a scarf. Not 5 minutes out.
You're good. You nervous?
I think if it was in the big room,
Yeah. Oh yeah. No.
Dude,
I would be melting now if I was in the presenter room.
I would be flying back to Poland already.
I'd be like, sorry guys, I'm sick. I'm changing jobs. I'm gonna be an electrician.
Very good.
yeah, this seems a little more local.
Yeah.
Yeah.
Yeah. Okay, so if we have trouble,
People don't pay attention. It seems better.
yeah, that's true. If we have trouble with the AV, you take over because you're gonna see better.
How
You know what I
long
mean?
is your, like, I thought it was 15 minutes.
Yeah.
I made mine like 13 minutes.
Our is like,
Ours might be right there on the limit. I feel.
yeah. At the
Yeah.
very beginning, it was like half an hour, and then
Yeah.
we like started trimming stuff, removing
Yeah.
slides. And,
Really?
Yeah.
Yeah.
I didn't even know there was a Q&A button.
Yeah. I don't think we will have time for the Q&A.
Ain't nobody got time for that.
Ain't nobody got time for Q&A, man. Gotta move on to the next talks.
Zapier must be really hard like Eval because the data is so...
Yes.
Yeah. You cannot optimize for any domain, right?
Indeed.
That's why I was telling you, at the dinner, there was someone from Perplexity.
Mm,
He was just saying like, we're
Yeah.
searching the entire like...
exactly. Yeah. Yeah, it's really difficult. Yeah.
So you mostly
It's like-
fail.
Yeah, we mostly bring like the average for everyone high, but it's still like not super good at any specific vertical. So we struggle with that a lot. Trying to work
But it's
like
part of the game.
yeah. It's like it's for the normies.
Oh, 100%.
Like,
Get behind the pillar.
yeah. It's like get people hooked into it, you know, and then
Especially more like, I think for us, evals really help us. They just gauge where you're at. Like,
Yeah.
you can't really know if you're improving. That's like my talk. It's like you don't know if you're improving.
Oh, yeah.
if you can't measure.
We have something really, really similar.
Yeah.
Actually, like we changed the model to Sonnet to newer Sonnet, and the scores like decreased all over the board. And we were like, what the fuck is this?
Yeah.
So
Even though it was obviously the best model because we were already like using it in cursor and everything. And I'm like,
What's up?
hey, what's up?
How you doing?
Hello.
how are you?
Ido, nice to meet you.
Ido?
Yeah,
Yes.
he works at Versailles.
Oh, nice. Good to meet you. I used to work at Zapier with these guys. But I abandoned them.
Yeah.
He also used to work at Zapier.
Omo, yeah.
Almost.
Yeah.
Yeah.
He's-
I'm excited for your talk. And Brain Trust is emceeing this whole track.
Yeah.
Almost
yeah.
almost up there.
They just got the whole track. Yeah.
Cool.
Yeah.
Makes sense.
Yeah.
I mean, not if you're a competitor, but
Yeah. True. True that.
y'all ready?
Yeah.
No. Perfect. Have you given a talk before? Like an
Not
inline,
not
this
like
size?
this fancy. No. No.
Yeah.
I've done a lot of like online talks.
Yeah.
Yeah.
When you
but,
did the course, you did.
Yeah. Yeah. Of
that-
course.
and that's where a
It's
lot of the content. is
much
from?
easier. I just don't look at any face. I just look at my presenter notes and I just zone out. I'm gonna try to do the same. I think.
Did you repurpose the content from?
A lot of it was repurposed, and then
Oh,
there's some
hopefully
new
it's the
stuff.
good stuff, right?
Yeah, there's some the good stuff repurposed, and then some new stuff.
Cool.
So like it's mixed, half and half.
We'll get longer and longer prompting guides for the latest models that are supposed to be, closer and closer to AGI. And if you're less lucky, you have to figure that out on your own, right? If you're even less lucky, the prompting guides from the provider are not even that good, so you have to actually kind of figure out what the right thing is. And every day, maybe at an even faster pace, someone is releasing an archive paper or a tweet or something that introduces a new learning algorithm, maybe some reinforcement learning bells and whistles, maybe some prompting tricks, maybe a prompt optimization technique, something or the other that promises to make your system learn better and sort of fit your goals better. Someone else is introducing some search or scaling or inference strategies or agent frameworks or agent architectures that are promising to finally unlock levels of reliability or quality better than what you had before. And I think if you're actually doing a reasonable job now, most likely, I've got to stay on top of at least some of this stuff so that I don't fall behind. And in many cases, model APIs actually change the model under the hood, even though you're using the same name. So it's actually you're forced to scramble. And actually, I would say maybe the question isn't whether you will scramble every week, or maybe a different question is, will you even get to scramble for long if you think about the rate of progress of these LLMs? Like, are they going to eat your lunch? Right? So these are, I think, questions that are on a lot of people's minds, and this is what the talk is going to be addressing. So the talk mentions the bitter lesson, which sounds like this really ancient, old kind of AI lore, but it's just 6 years old, where the current year's Turing Award winner, Rich Sutton, who's a pioneer of reinforcement learning, wrote this short essay on his website, basically, that says 70 years of AI has taught him and taught other people in the AI community from his perspective that when AI researchers leverage domain knowledge to solve problems, like, I don't know, chess or something, we build complicated methods that essentially don't scale, and we get stuck, and we get beat by methods that leverage scale a lot better. What seems to have to work better, according to Sutton, is general methods to scale, and he identifies search, which is not like retrieval, more of like exploring large spaces, and learning, so getting the system to kind of understand its environment, maybe, for example, work best. And search here is what we'd call in the LLM land maybe inference time scaling or something. So I don't speak for Sutton, and I'm not suggesting that I have the right understanding of what he's saying or that I necessarily agree or disagree, but I think this is just fundamental and important kind of concept in this space. So I think it raises interesting questions for us as people who build and engineer AI systems. Because if leveraging domain knowledge is bad, what exactly is AI engineering supposed to be about? I mean, engineering is understanding your domain and working in it with a lot of human ingenuity in repeatable ways, let's say, or with principles. So are we just doomed? Are we just wasting our time? Why are we at an AI engineering fair? And I'll tell you how to resolve this. I've not really seen a lot of people discuss that. Sutton is talking about, and a lot of people throw the bitter lesson around, so clearly somebody has to think about this, right? Sutton is talking about maximizing intelligence. All of us probably care about that to some degree, but which is something like the ability to figure things out in a new environment really fast, let's say. All of us kind of care about this to some degree. I'm also an AI researcher. But when we're building AI systems, I think it's important to remember that the reason we build software is not that we lack AGI. We build software, and the reason for this, and the way kind of to understand this, is we already have general intelligence everywhere. We have 8 billion of them. They're unreliable because that's what intelligence is, and they've not solved the problems that we want to solve with software. That's why we're building software. So we program software not because we lack AGI, but because we want reliable, robust, controllable, scalable systems. And we want these things to be things that we can reason about, understand at scale. And actually, if you think about engineering and reliable systems, if you think about checks and balances, in any case where you try to systematize stuff, it's about subtracting agency and subtracting intelligence in exactly the right places, carefully, and not restricting the intelligence otherwise. So this is a very different axis from the kinds of lessons that you would draw on from the bitter lesson. Now, that does not mean the bitter lesson is irrelevant. Let me tell you the precise way in which it's relevant. So the first takeaway here is that scaling search and learning works best for intelligence. This is the right thing to do if you're an AI researcher interested in building agents that learn really well, really fast in new environments, right? Don't hard code stuff at all, or unless you really have to. But in building AI systems, it's helpful to think about, well, sure, search and learning, but searching for what? Right? Like, what is your AI system even supposed to be doing? What is the fundamental problem that you're solving? It's not intelligence. It's something else. And what are you learning for, right? Like, what is the system learning in order to do well? And that is what you need to be engineering, not the specifics of search and not the specifics of learning, as I'll talk about in the rest of this talk. So he's saying, Sutton is saying, complicated methods get in the way of scaling, especially if you do it early, like before you know what you're doing, essentially. Did we hear that before? I feel like I heard that back in the 1970s, although I wasn't around. This is, the notion of structured programming with Knuth saying his popular, phrase in a paper, premature optimization is the root of all evil. I think this is the bitter lesson for software, and thereby also for AI software. So it's human ingenuity and human knowledge of the domain. It's not that it's harmful, it's that when you do it prematurely in ways that constrain your system, in ways that reflect poor understanding, they're bad. But you can't get away in an engineering field with not engineering your system, like you're just quitting or something, right? So here's a little piece of code. If you follow me on X, on Twitter, you might recognize it, but otherwise I think it looks pretty opaque to me in 3 seconds. And I can't really look at this and tell exactly what it's doing, and I also honestly don't really care. So lo and behold, this is computing a square root in a certain floating point representation on an old machine. And I think the thing that jumps at me immediately is this is not the most future-proof program possible. If you change the machine architecture, different floating point representations, better CPUs, first of all, it'll be wrong because it's just hard coding some values here. And the second of all, it'll probably be slower than a normal, square root that maybe is a single instruction, or maybe the compiler has a really smart way of doing it, or, a lot of other things that could be optimized for you, right? So someone who wrote this, maybe they had a good reason, maybe they didn't, but certainly if you're writing this kind of thing often, you're probably messing up as an engineer. So premature optimization is maybe the square root of all evil or something, but what counts as premature? That's kind of the name of the game, right? Like, we could just say that, but it doesn't mean anything. So I don't think any strategy will work in tech. Nobody can anticipate what will happen in 3 years, 5 years, 10 years. But I think you still have to have a conceptual model that you're working off of. And I happen to have built 2 things that are, on the order of several years old that have fundamentally stayed the same over the years, from the days of BERT, Text DaVinci 2, up to 04 Mini. And they're bigger now than they ever were. And they're sort of like these stable, fundamental kind of abstractions or AI systems around LLMs. So what gives? What happens in order to get something like Colbert or something like DSPy in this ecosystem and sort of endure a few years, which is like, centuries in AI land? I'll try to reflect on this, and, again, none of this is guaranteed to be something that lasts forever. So here's my hypothesis. Premature optimization is what is happening if and only if you're hard coding stuff at a lower level of abstraction than you can justify. If you want a square root, please just say, give me a square root. Don't start doing random bit shifts and bit stuff like, bit manipulation that happens to appease your particular machine today. But actually take a step back. Do you even want a square root, or are you computing something even more general? And is there a way you could express that thing that is more general, right? And only, stoop down or go down to the level of abstraction that's lower if you've demonstrated that a higher level of abstraction is not good enough. So I think the bigger picture here is applied machine learning and definitely prompt engineering has a huge issue here. Tighter coupling than necessary is known to be bad in software, but it's not really something we talk about when we're building machine learning systems. In fact, the name of the game in machine learning is usually like, hey, this latest thing came out, let's rewrite everything so that we're working around that specific thing. And I tweeted about this a year ago, 13 months ago, last May in 2024, saying the bitter lesson is just an artifact of lacking good high-level ML abstractions. Deep learning, scaling deep learning helps predictably, but after every paradigm shift, the best systems always include modular specializations, because we're trying to build software, we need those. And every time they basically look the same, and they should have been reusable, but they're not because we're writing code bad. But we're writing bad code. So here's a nice example just to demonstrate this. It's not special at all. Here's a 2006 paper. The title could have really been a paper now, right? A modular approach for multilingual question answering. And here's the system architecture. It looks like your favorite multi-agent framework today, right? It has an execution manager. It has some question analyzers and retrieval strategists from a bunch of corpora. And it's like a figure, if you color it, you would think it's a paper maybe from last year or something. Now, here's the problem. It's a pretty figure. The system architecturally is actually not that wrong. I'm not saying it's the perfect architecture. But in a normal software environment, you could actually just upgrade the machine, right? Put it on a new hardware, put it on a new operating system, and it would just work. And it would actually work reasonably well because the architecture is not that bad. But we know that that's not the case for these ML sort of architectures because they're not expressed in the right way. So I think fundamentally, I can express this most passionately against prompts. A prompt is a horrible abstraction for programming, and this needs to be fixed ASAP. I say for programming because it's actually not a horrible one for management. If you want to manage an employee or an agent, a prompt is a reasonably kind of like it's a Slack channel. You have a remote employee. If you want to be a pet trainer, working with tensors and objectives is a great way to iterate. That's how we build the models. But I want us to be able to also engineer AI systems. And I think for engineering and programming, a prompt is a horrible abstraction. Here's why. It's a stringly typed canvas, just a big blurb, no structure whatsoever, even if structure actually exists in a latent way. That couples and entangles the fundamental task definition you want to say, which is really important stuff. This is what you're engineering with some random over-fitted, half-baked decisions about, hey, this LLM responded to this language, when I talk to it this way. Or I put this example to demonstrate my point, and it kind of clicked for this model, so I'll just keep it in. And there's no way to really tell the difference. What was the fundamental thing you're solving, and what was the random trick you applied? It's like a square root thing, except you don't call it a square root, and we just have to stare at it and be like, wait, why are we shifting to the left by 5 bits or something? You're also using the inference time strategy, which is like changing every few weeks, or people are proposing stuff all the time, and you're baking it, literally entangling it into your system. So if it's an agent, your prompt is telling it it's an agent. Your system has no big deal knowing about the fact it's an agent or a reasoning system or whatever. What are you actually trying to solve, right? If you're writing a square root function, and then you're like, hey, here is the layout of the structs in memory or something. You're also talking about formatting and parsing things. Write in XML, produce JSON, whatever. Again, that's really none of your business most of the time. So you want to write a human-readable spec, but you're saying things like, do not ignore this, generate XML, answer in JSON, you are Professor Einstein, a wise expert in the field of, I'll tip you $1,000, right? That is just not engineering, guys. So what should we do? Trusty, old separation of concerns, I think, is the answer. Your job as an engineer is to invest in your actual system design and, starting with the spec. The spec, unfortunately or fortunately, cannot be reduced to one thing. And this is the time I'll talk about evals. I know everyone hears about evals, so this is the one line about evals that makes us talk about evals. A lot of the time, you want to invest in natural language descriptions because that is the power of this new framework. Natural language definitions are not prompts. They are highly localized pieces of ambiguous stuff that could not have been said in any other way, right? I can't tell the system certain things except in English, so I'll say it in English. But a lot of the time, I'm actually iterating to appease a certain model and to make it perform well relative to some criteria I have, not telling it the criteria, just tinkering with things. There, evals is the way to do this, because evals say, here's what I actually care about. Change the model, the evals are still what I care about. It's a fundamental thing. Now, evals are not for everything. If you try to use evals to define the core behavior of your system, you will not learn. Induction, learning from data, is a lot harder than following instructions, right? So you need to have both. Code is another thing that you need. You know, a lot of people are like, oh, it's just like a, you know, you just ask it to do the thing. Well, who's going to define the tools? Who's going to define the structure? How do you handle information flow? Like, you know, like things that are private should not flow in the wrong places, right? You need to control these things. How do you apply function composition? LLMs are horrible at composition because neural networks kind of essentially don't learn things that reliably. Function composition in software is always perfectly reliable, basically, right, by construction. So a lot of the things are often best delegated to code, right? But it's hard, and it's really important that you can actually juggle and combine these things. And you need a canvas that can allow you to combine these things well. When you do this, a good canvas, the definition here of a good canvas, or the criteria for a good canvas, is that it should allow you to express those three in a way that's highly streamlined and in a way that is decoupled and not entangled with models that are changing. I should just be able to hot swap models. Inference strategies that are changing. Hey, I want to switch from a chain of thought to an agent. I want to switch from an agent to a Monte Carlo tree search, whatever the latest thing that has come out is, right? I should be able to just do that. And new learning algorithms. So this is really important. We talked about learning, but learning is always happening at the level of your entire system if you're engineering it, or at least you've got to be thinking about it that way, where you're saying, I want the whole thing to work as a whole for my problem, not for some general default, right? So that's what the evals here are going to be doing. And you want a way of expressing this that allows you to do reinforcement learning, but also allows you to do prompt optimization, but also allows you to do any of these things at the level of abstraction that you're actually working with. So the second takeaway is that you should invest in defining things specific to your AI system and decouple from the lower level swappable pieces because they'll expire faster than ever. So I'll just conclude by telling you we've been building for 3 years this DSPy framework, which is the only framework that actually decouples your job from, which is writing the lower level AI software, from our job, which is giving you powerful evolving toolkits for learning and for search, which is scaling, and for swapping LLMs through adapters. So there's only one concept you have to learn. It is a new concept, which we call signatures, a new first-class concept. If you learn it, you've learned DSPy. I'll have to unfortunately skip this because of the time for the other speakers, but let me give you a summary. I can't predict the future. I'm not telling you if you do this, the code you write tomorrow will be there forever. But I'm telling you the least you can do. This is not like the kind of the top level. It's just like the baseline, I would say, is avoid hand engineering at lower levels than today allows you to do. Right? That's the big lesson from the bitter lesson and from premature optimization being the root of all evil. Among your safest bets, they could turn out to be wrong, I don't know, is models are not anytime soon gonna read specs off of your mind. I don't know if we'll figure that out. And they're not going to magically collect all the structure and tools specific to your application. So that's clearly stuff you should invest in, right, when you're building a system. Invest in the signatures, which again, you can learn about on the DSPy site, DSPy.ai. Invest in essential control flow and tools, and invest in evals for things that you would otherwise be iterating on by hand. And ride the wave of swappable models, ride the wave of the modules we build. You just swap them in and out, and ride the wave of optimizers, which can do things like reinforcement learning or prompt optimization for any application that it is that you've built. All right, thank you, everyone.
All right, we won't take up time on the computer. I think I learned that lesson. So for now, I'll go ahead and pick something, Llama 3. Let's see how it did.
Is this yours?
So here's the introduction, even though I asked it not to give me a preface. It's my pleasure to introduce our next speakers, Rafał Wilinski, also known as Rafał Wilinski, and Vitor Boloko, also known as Vitor Baloko, as the AI tech lead and staff AI engineer at Zapier. Recently, they'll share their insights on how to turn agent failures into opportunities for growth and improvement. And then it said, note, I've also used the phonetic pronunciation guides to help with the speakers' names, which are often tricky to pronounce for native speakers. So that's Llama 3 right there. All right, I'll let you all take it from here.
Cool. Thank you, Omo. How's everybody doing? I don't think I have a mic yet, so give me a sec.
Yeah. Oh, thank you.
Now is the time to take a selfie. Hey everybody, how's it going? We're Vitor and Rafal, and we're AI engineers at Zapier, and we're building Zapier agents. And today we would like to share a little bit with you some of the hard-won lessons about building agents that we learned from the past 2 years, building Zapier agents.
Yeah, a brief introduction to Zapier agents. I believe many of you know what Zapier is. This automation software, a lot of boxes, arrows, essentially about automating your business processes. Agents is just, well, more agentic alternative to Zapier. You describe what you want, we propose you a bunch of tools, a trigger, you enable that, and hopefully we automate your whole business processes. And a key lesson that we have after those 2 years is that building good AI agents is hard, and building good platform to enable non-technical people to build AI agents is even harder. That's because AI is non-deterministic, but on top of that, your users are even more non-deterministic. They are going to use your products in a way that you cannot imagine up front. So if you think that building agents is not that hard, you probably have this kind of picture in mind. You probably stumbled upon this library called LangChain. You pulled some examples, tutorial, you tweaked the prompt, pulled a bunch of tools, you chatted with this solution, and they thought, well, it's actually kind of working, all right? So let's deploy it, and let's collect some profit. Turns out the reality has a surprising amount of detail, and we believe that building probabilistic software is a little bit different than building traditional software. The initial prototype is only a start, and after you ship something to your users, your responsibility switches to building the data flywheel. So once your user starts using your product, you need to collect the feedback. You're starting to understand the usage patterns, the failures, so then you can build more Evals, build an understanding of what's failing, what are the use cases. As you're building more Evals and more features, probably your product is getting better, so you're getting more users, and there are more failures, and you have to build more features, and on and on and on. So yeah, it forms this data flywheel. But starting with the first step.
Okay, yeah. So starting from the beginning, how do you start collecting actionable feedback? Backing up for just a second, the first step is to make sure you're instrumenting your code, right? Which you probably already are doing. Whether you're using brain trust or something else, they all offer like an easy way to get started, like just tracing your completion calls. And this is a good start, but actually you also want to make sure that you're recording much more than that in your traces. You want to record the tool calls, the errors from those tool calls, the pre and post processing steps. That way it will be much easier to debug what went wrong with the run. And you also want to strive to make the run repeatable for eval purposes. So for instance, if you log data in the same shape as it appears in the runtime, it makes it much easier to convert it to an eval run later, because you can just pre-populate the inputs and expected outputs directly from your trace for free. And this is especially useful as well for tool calls, because if your tool call produces any side effects, you probably want to mock those in your evals. So you get all of that for free if you're recording them in a trace. Okay, great. So you've instrumented your code, and you started getting all this raw data from your runs. Now it's time to figure out what runs to actually pay attention to. Explicit user feedback is really high signal, so that's a good place to start. Unfortunately, not many people actually click those classic thumbs up and thumbs down buttons. So you got to work a bit harder for that feedback. And in our experience, this works best when you ask for the feedback in the right context. So you can be a little bit more aggressive about asking for the feedback, but you're in the right context. You're not bothering the user before that. So for us, one example of this is once an agent finished running, even if it was just a test run, we show a feedback call to action at the bottom, right? Did this run do what you expected? Give us the feedback now. And this small change actually gave us like a really nice bump in feedback submissions, surprisingly. So thumbs up and thumbs down are a good benchmark, a good baseline, but try to find these critical moments in your user's journey where they'll be most likely to provide you that feedback, either because they're happy and satisfied or because they're angry and they want to tell you about it. Even if you work really hard for the feedback, explicit feedback is still really rare. And explicit feedback that's detailed and actionable is even harder, because people are just not that interested in providing feedback generally. So you also want to mine user interaction for implicit feedback. And the good news is there's actually a lot of low-hanging fruit possibilities here. Here's an example from our app. Users can test an agent before they turn it on to see if everything's going okay. So if they do turn it on, that's actually really strong positive implicit feedback, right? Copying a model's response is also good implicit feedback. Even OpenAI is doing this for ChatGPT. And you can also look for implicit signals in the conversation. So here the user is clearly letting us know that they're not happy with the results. Here they're telling the agent to stop slacking around, which is clearly implicit negative feedback, I think. Sometimes the user sends a follow-up message that is mostly rehashing what I asked the previous time to see if the LLM interprets that phrasing better. That's also good implicit negative feedback. And there's also a surprising amount of cursing. Recently, we had a lot of success as well using an LLM to detect and group frustrations, and we have this weekly report that we post in our Slack. But it took us a lot of tinkering to make sure that the LLM understood what frustration means in the context of our products. So I encourage you to try it out, but expect a lot of tinkering. You should also not forget to look at more traditional user metrics, right? There's a lot of stuff in there for you to mine implicit signal too. So find what metrics your business cares about and figure out how to track them. Then you can distill some signal from that data. You can look for customers, for example, that churned in the last 7 days and go look at their last interactions with your product before they left, and you're likely to find some signal there.
Okay, so I have raw data. What now? I'll let the industry experts speak. Why is it not starting? Oh. Yeah, or the meetings will continue until everyone looks at their data. Okay, but how actually you're going to do that? So we believe that the first step is to either buy or build LLMOps software. We do both. You're definitely going to need that to understand your agent runs, because one agent run is probably multiple LLM calls, multiple database interactions, tool calls, REST calls, whatever. Each one of them can be source of failure, and it's really important to piece together this whole story, understand this, what caused this cascading failure. Yeah, I said we are doing both because I believe vibe coding your own internal tooling is really, really easy right now with Cursor and Cloud Code, and it's going to pay you massive dividends in the future for 2 reasons. First of all, it gives you an ability to understand your data in your own specific domain context. And the second of all, you should be also able to create a functionality to turn every single interacting case or every failure into an eval with the minimal amount of fraction. So whenever you see something interesting, there should be like a 1 click to turn it into an eval. It should become your instinct. Once you understand what's going on a singular run basis, you can start understanding things at scale. So now you can do feedback aggregations, clustering, you can bucket your failure modes, you can bucket your interactions, and then you're going to starting to see what kind of tools are failing the most, what kind of interactions are the most problematic. That's going to almost create for you like an automatic roadmap. So you'll know where to apply your time and effort to improve your product the most. Doing anything else is going to be a suboptimal strategy. Something that we are also experimenting with is using reasoning models to explain the failures. Turns out that if you give them the trace, output, input instructions, and anything you can find, they are pretty good at finding the root cause of a failure. Even if they are not going to do that, they're probably going to explain you the whole run or just direct your attention into something that's really interesting and might help you find the root cause of the problem.
Cool. So now you have a good short list of failure modes you want to work on first. It's time to start building out your evals. And we realized over time that there are different types of evals, and the types of evals that we want to build can be placed into this hierarchy that resembles the testing pyramid, for those of you that know that. So with unit tests-like evals at the base, end-to-end evals, or trajectory evals, how we like to call them, in the middle, and the ultimate way of evaluating using A/B testing with stage rollouts at the top. So let's talk a bit about those. Starting with unit test evals, we're just trying to predict the n+1 state from the current state. So these work great when you want to do simple assertions, right? For instance, you could check whether the next state is a specific tool call, or if the tool call parameters are correct, or if the answer contains a specific keyword, or if the agent determined that it was done, all the good stuff. So if you're starting out, we recommend focusing on unit test evals first, because these are the easiest to add. It helps you build that muscle of looking at your data, spotting problems, creating evals that reproduce them, and then just focusing on fixing them, right? Beware though of like turning every positive feedback into an eval. We found that unit test evals are best for hill climbing specific failure modes that you spot in your data. So now unit test evals are not perfect, and we realized that ourselves. We realized we had over-indexed on unit test evals when the new models were coming out that were objectively stronger models, but they were still performing worse in our internal benchmarks, which was weird. And because the majority of our evals were so fine-grained, this made it really hard to see the forest for the trees when benchmarking new models. There was always a lot of noise when we would try comparing runs. Like when you're looking at a single trace, it's easy to kind of go through the trace and understand what's happening. But when you need to kind of look at it from, I don't know how to put it again, sorry. When you want to look at it through an aggregation of many traces, then it starts getting difficult to understand what's happening. Why are so many of these passing and some of these are regressing?
Yeah, so we realized that maybe machine can help us. It turns out in that previous video when I was investigating one experiment inside Brain Trust, there is a lot of looking at that screen trying to figure out what went wrong. And we were like, hey, maybe we can like just give this old data to, once again, a reasoning LLM and compare the models for us. It turns out that with Brain Trust MCP and reasoning model, you can just ask it to, hey, look at this run, and tell me what's actually different about the new model that we are going to deploy. In this case, it was Gemini Pro versus Claude. And what the reasoning model found was actually really, really good. It found that Claude is like a decisive executor, whereas Gemini is really yapping a lot. It's asking follow-up questions. It needs some positive affirmations. And it's sometimes even hallucinating bad JSON structures. So yeah, it helped us a lot. It also surfaces a problem with unit test evals a lot, which is different models have different ways of trying to achieve the same goal. And unit test evals are penalizing different paths. They're like hard-coded to only follow one path. And yeah, our unit test evals were overfitting to our existing models, or actually data collecting using that model. So what we started experimenting with is trajectory evals. Yeah, instead of grading just one iteration of an agent, we let the agent run till the whole, till the end state. And we are not grading just the end state, but we are also grading all the tool calls that were made along the way and all the artifacts that have been generated along the way. This can be also paired with LLM as a judge. Vitor is going to speak about it later. Yeah, but they are not free. I think they have really high return on investment, but they are much harder to set up, especially if you are evaluating runs that have tools that cause side effects, right? When you are running an eval, you definitely don't want to send an email on behalf of the customer once again, right? So we had a fundamental question whether we should mock environment or not, and we decided that we are not going to mock the environment because otherwise you're going to get data that is just not reflecting the reality. So what we started doing is just mirroring user's environment and crafting a synthetic copy of that. Also, they are much slower, right? So they can sometimes take like up to an hour, so it's not pretty great.
And we're also learning a bit more into LLM as a judge. This is when you use an LLM to grade or compare results from your evals. And it's tempting to lean into them for everything, but you need to make sure that the judge is judging things correctly, which can be surprisingly hard. And you also have to be careful not to introduce subtle biases, right? Because even small things that you might overlook might end up influencing it. Lately, we've also been experimenting with this concept of rubrics-based scoring. We use an LLM to judge the run, but each row in our data set has a different set of rubrics that were handcrafted by a human and describe in natural language what specifically about this run should the LLM be paying attention to for the score. So one example of this, did the agent react to an unexpected error from the calendar API and then try it again? So to sum it up, here's our current mental model of the types of evals that we build for Zapier agents. We use LLM as a judge or rubrics-based evals to build a high-level overview of your system's capabilities. And these are great for benchmarking new models. We use trajectory evals to capture multi-turn criteria, and we use unit tests-like evals to debug specific failures. He'll climb them, but beware of overfitting with these.
Yeah, and a couple of closing thoughts. Don't obsess over metrics. Remember that when a good metrics become a target, it ceases to be a good target. So when you're close to achieving 100% score on your eval dataset, it's not meaning that you're doing a good job. It's actually meaning that your data set is just not interesting, right? Because we don't have AGI yet, so it's probably not true that your model is that good. Something that we're experimenting with lately is dividing the data set into two pools, into the regressions data set to make sure that we are making any changes, we are not breaking existing use cases for the customers, and also the aspirational data set of things that are extremely hard, for instance, like nailing 200 tool calls in a row. And lastly, let's take a step back. What's the point of creating evals in the first place? Your goal isn't to maximize some imaginary number in a lab-like setting. Your end goal is user satisfaction. So the ultimate judge are your users. You shouldn't be optimizing for the biggest scores for the evals and completely disregard the vibes. So that's why you think the ultimate verification method is an A/B test. Just take a small proportion of your portion of your traffic, let's say 5%, and route it to the new model, route it to the new prompt, monitor the feedback, check your metrics like activation, user retention, and so on. Based on that, probably you can make the most educated guess instead of being in the lab and optimizing this imaginary number. That's all. Thank you. Oh, good.
We have time for a couple of questions, like one or two. There's a mic here on the left and another mic right there for anybody that wants to ask a question for Vitor and for Eval.
Oh yeah, I'll stay.
Yeah.
Oh.
Anybody interested? You can also raise your hand and
It was not interesting.
you can also say the question, and if you don't mind, Vitor, repeat it.
Mic 5, hey, I'm here. The question I had for you was, you mentioned at the very end, you were talking about splitting these things up into 3 different data sets. Do you combine that with like the rubrics thing to sort of create like a map of like how things end up looking? Or like how does that actually end up driving product decisions and like everything in general?
Yeah, great question. We're still experimenting with the rubrics-based evals. And I think they're really useful when you want to eval really long trajectories, or especially useful when you want to compare like a new model that just came out. But I think ultimately the combination of all the different evals is what tracks our product roadmap, right? Especially when we look at things in aggregate and we group things in buckets, and then we know, okay, this is the most important thing that we have to focus now. And then we can kind of go and like slice our data sets to find which part of that data set like is most representative for us to kind of iterate over. And of course, afterwards, we run the complete data set as well to catch any regressions, but that's kind of how we think about it. Yeah.
Cool. Do we have another question over there?
Yeah, one more question here. I'm Drew from Pi Labs. I was really curious what your process for like evaling and aligning your eval looked like. Was that a pretty time-consuming thing? It's something we've struggled with and met a lot of people who've struggled with. So,
Cool. You want to take that?
Yeah, sure. So first of all, I think we start building evals by looking at the customer feedback, especially the negative customer feedback. We used to have labeling parties where we like group together and we are looking at the trace and we are trying to understand what went wrong and what's the expected behavior. We also have Slack channel and we have something like an on-call rotation. There's always like one engineer that just looks at it and does its best to find a problem. Yeah, but there is no like really hard process for that. I think it's best effort, I would say. Yeah.
Yeah, and we kind of stumbled through different types of evals over time. We started like with big long trajectory evals, so them as a judge. Then we doubled down on unit test evals and kind of neglected the rest. And now we're feeling a bit of the pain from that. So in the end, we kind of spread out over different types of evals. And we're still kind of building that intuition about what a ratio of those should be.
Yeah.
All right. Thank you, folks.
Correct.
Good luck.
All right. So,
Thank you.
in case folks came in at the last second, what I'm doing is I actually have Eval Vive presenting, and I have some multiple models here.
Thank you.
So let's try Claude 4.
Was good?
So
Really?
up next we have Ido Pesuk,
Good signal.
an
That's a good
AI
consistent
engineer
signal.
at Vercel, who's been deep in the trenches building the AI systems behind V0, Vercel's AI-powered web development tool.
He's here to share hard-won
there were more
wisdom
people
about why
during
evaluating
our
AI
talk
systems
than the
requires
previous
throwing
one.
out everything
The
you
previous
thought
guy
you
is
knew
like-
about testing, because
Yeah,
when
it's like
your
super
system
famous.
is non-deterministic, your evals need to be anything but conventional. All right, take it away.
Thank you.
It was
Hello, everyone.
Yeah.
Let's see.
Please get away from
Hopefully my slides go out. 1 second. Awesome. Okay, thank you so much for coming. My name is Ido. I'm an engineer at Vercel working on V0. If you don't know, V0 is a full-stack vibe coding platform. It's the easiest and fastest way to prototype, build on the web, and express new ideas. Here are some examples of cool things people have built and shared on Twitter. And to catch you up, we recently just launched GitHub Sync, so you can now push generated code to GitHub directly from V0. You can also automatically pull changes from GitHub into your chat, and furthermore, switch branches and open PRs to collaborate with your team. I'm very excited to announce we recently crossed 100 million messages sent, and we're really excited to keep growing from here. So my goal of this talk is for it to be an introduction to evals, and specifically at the application layer. You may be used to evals at the model layer, which is what the research labs will cite in model releases. But this will be a focus on what do evals mean for your users, your apps, and your data. The model is now in the wild, out of the lab, and it needs to work for your use case. And to do this, I have a story. It's a story about this app called Fruit Letter Counter. And if the name didn't already give it away, all it is an app that counts the letters in fruit. So the vision is we'll make a logo with ChatGPT. There might be product market fit already because everyone on X is dying to know the number of letters in fruit. If you didn't get it, it's a joke on the how many R's are in strawberry prompt. We'll have V0 make all the UI and backend, and then we can ship. So we had V0 write the code. It used AI SDK to do the stream text call. And what do you know? It worked first try. GPT 4.1 said 3. And not only did it say 3 once, I even tested it twice, and it worked both times in a row. So from there, we're good to ship. Right? Let's launch on Twitter. Want to know how many letters are in a fruit? Just launched fruitlettercounter.io. The .com and .ai were taken. And yeah, everything was going great. We launched and deployed on Vercel. We had Fluid Compute on until I suddenly get this tweet. John said, I asked how many R's in strawberry, and it said 2. So, of course, I just tested it twice. How is this even possible? But I think you get where I'm going with this, which is that by nature, LLMs can be very unreliable. And this principle scales from a small letter counting app all the way to the biggest AI apps in the world. The reason why it's so important to recognize this is because no one is going to use something that doesn't work. It's literally unusable. And this is a significant challenge when you're building AI apps. So I have a funny meme here, but basically AI apps have this unique property. They're very like demo savvy. You'll demo it, it looks super good, you'll show it to your coworkers, and then you ship to prod, and then suddenly hallucinations come and get you. So we always have this in the back of our head when we're building. Back to where we were, let's actually not give up, right? We actually want to solve this for our users. We want to make a really good fruit letter counting app. So you might say, how do we make reliable software that uses LLMs? Our initial prompt was a simple question, right? But maybe we can try prompt engineering. Maybe we can add some chain of thought, something else to make it more reliable. So we spent all night working on this new prompt. You're an exuberant, fruit-loving AI on an epic quest, ... And this time, we actually tested it 10 times in a row on ChatGPT, and it worked every single time, 10 times in a row. It's amazing. So we ship, and everything was going great until John tweeted at me again, and he said, I asked how many R's are in strawberry, banana, pineapple, mango, kiwi, dragon fruit, apple, raspberry, and it said 5. So we failed John again. Although this example is pretty simple, but this is actually what will happen when you start deploying to production. You'll get users that come up with queries you could have never imagined, and you actually have to start thinking about how do we solve it. And an interesting thing, if you think about it, is 95% of our app works 100% of the time. We can have unit tests for every single function, end-to-end tests for the auth, the login, the sign out. It will all work. But it's that most crucial 5% that can fail on us. So let's improve it. Now, to visualize this, I have a diagram for you. Hopefully, you can see the code. Maybe I need to make my screen brighter. Can you see the code? I don't know. OK. OK, well, we'll come back to this. But basically, we're going to start building evals. And to visualize this, I have a basketball court. So today's day 1 of the NBA Finals. I don't know if you care. You don't need to know much about basketball. But just know that someone is trying to throw a ball in the basket. And here, the basket is the glowing golden circle. So blue will represent a shot make, and red will represent a shot miss. And one property to consider is that the farther away your shot is from the basket, the harder it is. Another property is that the court has boundaries. So this blue dot, although the shot goes in, it's out of the court, so it doesn't really count in the game. Let's start plotting our data. So here we have a question, how many R's in strawberry? This, after our new prompt, will probably work, so we'll label it blue. And we'll put it close to the basket because it's pretty easy. However, how many R's are in that big array? We'll label it red, and we'll put it farther away from the basket. Hopefully you can see that. Maybe we can make it a little bit brighter. But this is the data part of our eval. Basically, you're trying to collect what prompts your users are asking, and you want to just store this over time and keep building it and store where these points are on your court. 2 more prompts I want to bring up is like, what if someone says, how many R's are in strawberry, pineapple, dragon fruit, mango after we replace all the vowels with R's, right? Insane prompt, but it's still technically in our domain. So we'll label it as red all the way down there. But a funny one is like, how many syllables are in caret? So this, we'll call it out of bounds, right? This, none of our users are actually going to ask. It's not part of our app, so no one is going to care. I hope you can see the code. But basically, when you're making eval, here's how you can think about it. Your data is the point on the court. Your shot, or in this case in Brain Trust, they call it a task, is the way you shoot the ball towards the basket. And your score is basically a check of did it go in the basket or did it not go in the basket. To make good evals, you must understand your court. This is the most important step. And you have to be careful of falling into some traps. First is the out-of-bounds traps. Don't spend time making evals for your data your users don't care about. You have enough problems, I promise you, of queries that your users do care about. So be careful not try and be productive, and you're making a lot of evals, but they're not really applicable to your app. And another visualization is don't have a concentrated set of points. When you really understand your court, you're going to understand where the boundaries are, and you want to make sure you test across the entire court. A lot of people have been talking about this today, but to collect as much data as possible, here are some things you can do. First is collect thumbs up, thumbs down data. This can be noisy, but it also can be really, really good signal as to where your app is struggling. Another thing is if you have observability, which is highly recommended, you can just read through random samples in your logs. Although users might not be giving you signal, but if you take like 100 random samples and go through it like once a week, you'll get a really good understanding of what your users and how your users are using the product. If you have community forums, these are also great. People will often report issues they're having with the LLM, and also X and Twitter are also great but can be noisy. And there really is no shortcut here. You really have to do the work and understand what your court looks like. So here is actually what, if you are doing a good job of understanding your court and a good job of building your data set, this is what it should look like. You should know the boundaries. You should be testing in your boundaries. And you should understand where your system has blue and versus where it has red. So here it's really easy to tell, OK, maybe next week we need to prioritize the team to work on that bottom right corner. This is something where a lot of users are struggling, and we can really do a good job on flipping the tiles from red to blue. Another thing you can do, and I really hope you can see, but you want to put constants in data, variables in the task. So just like in math or programming, you want to factor constants so it improves clarity, reuse, and generalizations. if you have, let's say you want to test your system prompt, right? Keep the constant data that your users are going to ask. So for example, how many R's in strawberry, that goes in the data. That's a constant. It's never going to change throughout your app. But what you're going to test is in that task, you're going to try different system prompts. You might try different pre-processing, different RAG. And that's what you want to put in your task section. This way, your app actually scales, and you never have to, let's say, when you change your system prompt, redo all your data. And this is a really nice feature of Brain Trust. And if you don't know, AI SDK actually offers a thing called middleware, and it's a really good abstraction to put basically all your logic of pre-processing, so RAG, system prompt you can put in here, et cetera. And you can now share this between your actual API route that's doing the completion and your evals. So if you think about the court, the basketball court, as if we're going like basketball practice, and we're trying to practice our system across different models, you want your practice to be as similar as possible to the real game. That's what makes a good practice. So you want to share pretty much the exact same code between the evals and what you're actually running. Now, I want to talk a little bit about scores, which is the last step of the eval. The unfortunate thing is it does vary greatly depending on your domain. So in this case, it's like super simple. You're just checking if the output contains the correct number of letters. But maybe if you're doing writing, a task like writing, that's very, very difficult. From principles, you want to actually lean towards deterministic scoring and pass-fail. This is because when you're doing debugging, you're going to get a ton of input and logs, and you want to make it as easy as possible for you to actually figure out what's going wrong. So if you're over-engineering your score, it might be very difficult to share with your team and distribute across different teams your evals, because no one will understand how these things are getting scored. Keep your scores as simple as possible. And a good question to ask yourself is, when you're looking at the data, what am I looking for to see if this failed? Right? So with V0, we're looking for if the code didn't work. But maybe for writing, you're looking for certain linguistics. Ask yourself that question and write the code that looks for you. There are some cases where it's so hard to write the code that you may need to do human review, and that's OK. At the end of the day, you want to build your core and you want to collect signal. Even if you must do human review to get the correct signal, don't worry. If you do the correct practice, it will pay off in the long run, and you'll get better results for your users. One trick you can do for scoring is don't be scared to add a little bit of extra prompt to the original prompt. So for example, here we can say output your final answer in these answer tags. What this will do is basically make it very easy for you to do string matching and et cetera, whereas in production you don't really want this. But yeah, you can do some little tweaks to your prompt so that scoring is easier. Another thing we really highly recommend is add evals to your CI. So Brain Trust is really nice because you can get these eval reports. So it will run your task across all your data, and then it will give you this report at the end for the improvements and regressions. Assume my colleague made a PR that changes a bit of the prompt. We want to know, how did it do across the court, right? Visualize, did it change more tiles from red to blue? Maybe now our prompt fixed one part, but it broke the other part of our app. So this is a really useful report to have when you're doing PRs. So yeah, going back, this is the summary of the talk. You want to make your evals a core of your data. And this, you can treat it like practice. Your model is basically going to practice. Maybe you want to switch players, right? When you switch models, you can see how a different player is going to perform in your practice. But this gives you such a good understanding of how your system is doing when you change things like maybe your RAG or your system prompt. And you can now go to your colleague and say, hey, this actually did help our app, right? Because improvement without measurement is limited and imprecise. And evals give you the clarity you need to systematically improve your app. When you do that, you're going to get better reliability and quality, higher conversion and retention, and you also get to just spend less time on support and ops, right? Because your evals, your practice environment will take care of that for you. And if you're wondering about how I built all these court diagrams, I actually just used V0, and it made me some app that I just added these shots made and missed in the basket. So yeah, thank you very much. I hope you learned a little bit about evals.
Thank you. So we do have some time for some questions. There are 2 mics, one over here, one over there. I can take 2 or 3 of those, please, if anybody's interested in asking. We have one over there. Mic 5, please. Or you can repeat the question as well, if you don't mind.
Yeah. Yeah, you can think of it, it's really like practice. Like maybe you're a basketball player will like, you know, in general score like 90%, but they might miss more shots here or there. If you run it, like we do it like we run every day at least, and then we get a good sense of like where are we actually like failing? Did we have some regression? So yeah, running it like daily or at least in some schedule will give you a good idea.
I was thinking, what if you ran like, you know, the same question through it 5 times, right? It's like,
yeah.
Like, what's the percentage? It's making it 4 out of 5, or you know, 5
Oh,
out
I
of
see.
5, right?
So it's definitely like as you go further away, like the harder questions get like lower pass rates. But overall, you can measure that too. Like how is it running like 4 out of 5 like a week or something? And you just want to improve that. Evals are just a way to measure so you can actually do the improvement.
Yeah. Hello. I have a question about V0 evaluation, like real evaluation.
Yeah.
As I understand, you have a lot of trajectories. User trajectories, internal one. So it's not about analyzing one trajectory, but hundreds or even thousands. So the question is, how do you analyze, which method do you use to analyze thousands of trajectories and getting valuable insights from it at scale?
Yeah, so V0 is in a special domain because we're doing code, so we actually like run the code. When you run in V0, we can collect errors. So we do a lot of measurements based on those errors that we get. However, if you have a task like writing or something else that's like more difficult to measure, you might be in a worse spot where you need more human evals. But what we do is, we track a lot of it like errors in the apps, and that usually is a good signal for the final trajectory of like the app that user is building. Does that make sense?
I'm also interested about how do you analyze which tools was called and how properly it was called. Like it's undeterministic and it's interesting how to understand it.
So we also found like the Zapier presentation earlier. You want to just look like the best thing is look at the final output. You can get a little carried away with looking at every tool call, but at V0 because it's like did the app work? A lot of times that's after all the steps in the between, and that's what we really look at. Is like, did the thing work at the end or not? And then if it didn't work, then we go in and we look at like all the steps and kind of try to find the one that broke. But we start with looking at the final trajectory, like after all the steps happened. Yeah.
Okay. Yes. Thank you.
Awesome.
And then we have one more on the side.
Yeah. How do you think about evals in terms of like each user query in like a full conversation? Do you, like, I know you were just talking about kind of like thinking through like the whole thing, but like what if the user doesn't know where they're going at the end? And
yeah, so for V0, like the conversations can get really long. I would equate that to like just a more difficult, like that's like actually a different data point. I would equate that to like a very difficult shot on the court. And we test those separately. So like maybe you can have multiple evals within one chat, like depending on where they are in the conversation. And you want to just, at that point, you test like one message at a time. But yeah, does that answer your question?
Yeah, somewhat. Thanks.
Awesome, thank you.
Yeah, did you have one really quickly?
Yeah, I was going to ask how you deal with if you have an error that's like 3 or 5 turns into a conversation and you need to mock up to that state and figure out whether it's able to resolve it from there.
Yeah, that's a good question. So on V0, like we have the state at every point. So we were lucky, so we can kind of really easily traverse that state. But what we do is, again, like I was saying earlier, we basically, on our evals, you test like one message ahead. And if they got into a broken state already, then it's not really worth testing anymore because usually like the LLMs like really suck at coming back from it. So we're mostly focused on like finding, where was that point where it did break? And you want to try to reduce those number of points. Maybe in the future, as they get better, you can start, and we're working on it, like a better loop of like error correction. This is something we're constantly working on.
Sure.
But usually it's really helpful to find like, that one point where it ended.
Okay, so go up
All right.
from there. Makes sense.
Thank you all. Thank you, Ito.
Thank you.
Yeah, the remainder time.
appreciate that. So we do have one remaining speaker, but they're not in right now. So feel free to stick around. Hopefully he shows up. Otherwise,
thank you so
there's
much.
also lunch available, right?
Thank you
If I'm
so
not
much.
mistaken?
Appreciate it.
All right.
Oh yeah, I was like thinking, how do I visualize this? And I was like, I was actually talking to Ankur about that.
All right, so we have a guest speaker, actually. If you don't mind introducing yourself, because I don't think even the LLM, yeah, go for it.
Hey, my name is Randall. I just launched a framework today for Evals that I'm trying to figure out if it's good. It's called Foundry. Well, that's our company name. And we are trying to help people who do JavaScript. Most people who do JavaScript don't have a great way to run evals or create synthetic data. We have a different approach that is based on journalism, actually, building prompts through a structured way that's more similar to like the way a newspaper is written than the way most people do, where they scare the crap out of a LLM. Let's see if I can plug in. This is totally guerrilla, but no one else is here, so why not, right? All right, let's do this. So it's live on GitHub right now. If you want to go, github.com/BoldFoundry or just boldfoundry.com has our thing. All right, cool. So let me spin up my environment. And the cool thing is that to start, you can just run npx bff-eval. And then we have a demo that you can run, --demo. And what this does is it will create, it all works with OpenRouter, so you can test against like any system that you want. Like you can, oh, this is a replit bug. Hold on, let me fix this really quick. Shell. All right, one more time. BFF, npx, bff-eval-demo. So here we've made a simple JSON validator. Rather than write the JSON validator to actually parse the JSON, this actually is a grader. So a grader is like someone who, it's a LLM that you can use to figure out if your thing is good. We have a set of samples. Let me just grab them. Samples.jsonl. Let's do this one, sure. That's the wrong one, but it's okay. So essentially, the messages come in as a user message, an assistant response, and then optionally a score. So you can actually set your ground truth and say, this is a sample of something that's really good. This is a sample of something that's really shitty. And then you can describe it. The description is mostly for your team, so that when you have like they were talking about, if you're pulling something from production and you have a sample that you want your team to know about, you can describe like why this is relevant. The eval runs, in this case we have 10 runs, each have a rubric score from +3 to -3. And the other person's here now, so thank you so much for letting me show you something cool, boldfoundry.com. Oh, I have a minute left, all right. So the other cool thing is, I'll just show you the end. You can actually see where your grader diverged from the ground truth. So you can say like, oh, this is weird. Why is this one acting this way? Anyway, we're gonna have more stuff. It's gonna be cool. Thanks, man. Thank you for giving me a second.
Yeah, no problem. All right. Next up, Diego. I had your introduction ready, but hopefully you don't mind if you introduce yourself. Go ahead and set up, connect the USB there, and then the HDMI there. There's no audio on your computer?
I just project?
Yeah.
I'm happy to project, that's fine. Okay.
Yeah, I'm going to give this mic.
Sorry, I thought you were in the right room. Yeah. Like it just gave me, for context, everyone just gave me like some instructions that I was supposed to be there, and then I was like, wait, there's someone else is starting. So did you do A? Interesting. So I'm gonna have to go there afterwards. Oh wow.
I'll make it announcement now.
Yeah, mirror. And then you can use this one. There's one here that I think you can use.
Hello.
I'm gonna go back there.
Okay, cool. Ooh, ooh, ooh. Okay. Yeah. That makes sense. Are we starting like very, very soon, or should I wait a few minutes? Yeah. And hello. Test 1 2 1 2 1 2. Okay. Good. Okay. Perfect. Cool. Should be relatively short too, so we have time. We can wait a few minutes, if that's better. Okay. Cool. I'm gonna start. Okay. So hello everyone. My name is Diego Rodriguez. I'm the co-founder of Krea, a startup in the AI space like many others, in particular generative media, multimedia, multimodal, and all the buzzwords. But I come here mainly to tell a story about how we think about evaluations when we have to take into account human perception and human opinion and aesthetics into the mix, right? So I'm going to start with a very simple story. It's like I put an AI-generated image of a hand. Obviously, it looks horrible. And then I asked O3, what do you think of this image? Then it thought for 17 seconds. Obviously, tool calling, does Python analysis, OpenCV, goes crazy. And then after it charges me a few cents, it's like, oh, just a couple melting jumps out. It's like, it's mostly natural, but like, and it's like, okay, we have like what many people claim is basically AGI, and it is completely unable of answering a very simple question. And like, that's a surprising thing if you think about it, because we as humans, when people see that image, is like we just react so naturally, right? Against that is like, oh, what is that? Like that's not natural. And I feel like that's precisely what AI models are being trained on. On human data, right? Second, on human preference data. And third, like in a way limited by the data that we humans made based on our preconceived notions and perception and all of that. So that's what this talk is about what can we do better, and honestly, to ask ourselves some questions that I think are not being asked enough in the field. Cool. So a tiny bit of history. We all know about Claude Shannon, that is, the father of information theory. And according to many, his master thesis is one of the most important master theses in the world, where he laid foundations for digital circuits and then eventually communication and all. And to a degree, we can say that even LLMs nowadays, right? If we fast forward. And I wanna focus on the fact that we call his work foundational in information theory. Well, when he published it, it was actually called mathematical foundation for communication theory. And he was always focused on communication. There's this image, appears on that work, and it's all about, okay, this is the source, this is the channel, this is the destination, there can be some noise there. And as a founder of a company that is focusing on media, to me, it's interesting to realize like these parallels between classic information theory and communication. Let me see, did I put the image? Let's see. Well, I didn't put the image, but if you have any context around variational autoencoders or neural networks and whatever, you can squint and be like, oh, is that a neural network, right? And in the context of information and communication, I want to talk about how compression is going to be related to how we think about evaluation, right? I'm going to talk for example on JPEG. JPEG exploits like human nature in the sense that we are very sensitive to brightness, but not so much to color. And this is an illusion that also talks about that, where A and B is actually the same color, but we are basically unable to perceive it until we do this. And then suddenly it's like, oh, really? And it's kind of like, what's going on there, right? And so JPEG just does the same thing where, okay, we have RGB color space to represent images with computers. We notice that there's a diagonal that represents the brightness of the images. We can change into a different color space that separates color versus brightness. And then we can downsample the channels around color because we are actually not even that sensitive to it. So we can remove that or parts of it. And then once we do that, this is an image where we can see the brightness and color components separated. Once we downsample, we can try to recreate the image. And this is an example of like basically original image and then the image with the downsample color looks the same to us, and the image is like 50% less information, right? And other stuff. There's Huffman coding and more stuff, but like the point is the same, right? And then the thing is, if you exploit the same for audio, like what can we hear, what can we not hear? Well, you do the same and we have MP3. And then if you do the exact same thing across time, well, congrats, now you have MP4. It's like, it's all this principle of like, let's exploit how we humans perceive the world, right? But this made me think about myself because I studied audiovisual systems engineering, which is engineering around all of these, how microphones work, how speakers work. And it was just interesting to me that I was coding. I start deleting information. I know for a fact that I'm deleting information, yet, and then I re-render the image, and I see the same. It's like philosophers always tell you about like, oh, we are limited by our senses, but like this is the first time that I was like, I'm seeing it, right? Like I am not seeing the difference. But then, if a lot of our data is the internet, right? Like we're scraping data from the internet, bunch of those images are also compressed, right? Like, are we taking into account that perhaps our AIs are limited too? Because we're kind of like we have some sort of contagion going on of our flaws into the AI. And then it gets more tricky because, for instance, this is just a screenshot I took from a paper. I think it's called Clean FID. And FID scores, for all of you who don't have context, is one of the standard metrics used for how well, for instance, diffusion models are reproducing an image. But then you start adding JPEG artifacts, and the score is like, oh, no, this is horrible, horrible image. And it's like, perceptually, the 4 images are basically the same. Yet, the FID score is like, no, this is really bad. So then it's like, why are we using FID scores or metrics along those lines to decide how this generative AI model is good or bad, right? So the thing is, sometimes I feel like we are focused on measuring just things that are easy to measure, right? Like prompt adherence with clip, how many objects are there, is this blue, is this red, etc. But what about here? Oh, it's like, oh no, really bad generator because that's not how clock looks, and the sky, that makes no sense. And it's like, okay, how not only are we limiting our AIs by our human perceptions, on top of that, we forget about the relativity of metrics, right? Like, no, actually, this is art, and this is great, and there's sometimes meaning behind the work that is not, like, it is conveyed in the image, but only if you're human. You get it, right? Like, oh, this is what the author is trying to tell me. But I feel like the metrics don't show that. And kind of like, commercially and professionally, my job is kind of like, okay, how can we make a company that allows creatives, artists of all sorts, we can start with image, we can start with video, but to better express themselves, But how are we supposed to do that if this is kind of like the state of the art, right? Then a friend of mine, Cheng Lu, actually he works at Midjourney. He has great talks that you should all check, but he told me once, a little bit over a year ago, a quote that I just can't stop thinking about, which goes something like, hey man, if you think about it, like predicting the car back when everything was horses, it's not that hard. I was like, well, like, yeah, it's not that hard to like, oh, cars are the future and whatever. It's like we have a thing that goes like this. We have horses that make energy, so you swap the thing for the engine. That's essentially a car, right? It's like, come on, how hard is that? It's like, you know what's hard to predict? Traffic, right? And then I just kept thinking about it. I was like, oh man, like, as engineers, as researchers, as founders, what are the traffics that we're missing now? Because I feel like everyone's focused on like, yeah, but you can, I don't know, transform from JSON to YAML. And like, who cares? That dude, who cares? Like, or yes, it's important, right? Like, but what kind of big picture are we all missing, right? Then he talks about, well, you know, the myth of the Tower of Babel, where in a nutshell is like God, like we want to go and meet God, and then he's like, no, I don't want that. So instead, I'm just going to confuse all of you, and then you're not going to be able to coordinate. And then each one is going to speak a different language, and then it's just basically going to be impossible to keep the thing going, which like reminds me of like a standard infrastructure meetings with backend engineers. It's like, no, we should use Kubernetes. No, we should use, and it's like, it's just all fighting and whatever, and nothing gets built. And I'm like, dude, God is winning. God damn it. But then, this makes me think about like, we just entered the age where you can have models. Essentially, they solve translation, right? Or they solve it to a very high degree. So what happens now that we can all speak our own languages, yet at the same time communicate with each other? I'm already doing it. For instance, I do sometimes customer support manually for Korea, and I literally speak Japanese with some of my users, and I don't speak Japanese. I learn a little bit, but I don't speak it. And like, I'm now able to provide an excellent founder-led, whatever that means, customer support level to a country that otherwise I would be unable to do, right? And so I invite us all to think about what that really means. Because this, for instance, means that we can now understand better or transmit our own opinion better to others. And on the previous point that I was talking about with the art, that's kind of like an opinion, right? Like, evals are not just about, are there 4 cats here? It's about, this cat is blue. And it's like, yeah, but is it blue or is it teal? What kind of blue? And I don't like this blue, and all of that. So, like, in a nutshell, it's like, how do we eval our evals, right? Like, from my opinion, this is bad. Then I want metrics that take into account my opinion too. And then it's like, okay, consider myself I may be a visual learner. What that means is like, maybe your eval should take into account how we humans perceive images, right? So, and also the nature of the data, such as, oh, it's all trained on JPEG on the internet, so take into account the artifacts, take into account like all of these while training your data. Okay, I guess mandatory slide before the thank you. Bunch of users, bunch of money. We did all of that with 8 people. Now we're 12. This is an email that I set up today for high priority applications for anyone who wants to work on research around aesthetics research, hyper-personalization, scaling generative AI models in real time for multimedia, image, video, audio, 3D across the globe. We have customers like those. And that's it. Thank you. Oh, here. Q&A? Okay, perfect. Any questions? Yeah, there's many points there. Can you like reframe the question? Like. Yeah. 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 So the question, like in a nutshell, is like, are there perceptually aware metrics, right? Like okay, I showed an example of FID score. It changes a lot with JPEG artifacts. Are those where it's almost like the opposite, barely changes, and the metric is still good? Like there are some, and many of these are used also in traditional encoding techniques. But in a way, I'm here to invite us all to start thinking about those, we can actually train, I mean, it's called a classifier, right? Like, or a continuous classifier. We can train so that it understands what we mean, and it's like, hey, I show you these 5 images. These 5 images are actually all good, and then they can have all sorts of artifacts, not just JPEG artifact. And this is exactly where machine learning excels, right? When it's all about opinions, and it's like, let me just know, and you will know. You know what you will know when you see it. That's precisely the type of question that AI is amazing at.
All right, thank you, everyone. We are.
Thank you.
He'll be sticking around for questions on the side if you have some. Thank you. And we are doing a working lunch.
like 3, right? Okay, so check it out. It'll give you a graphic EQ analyzer. If you hit it again, check, 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 check. Oh, it doesn't do it in the main, but check it out. I go to the individual channel. No, in the individual channel. I hit it again. There it is. It's an analyzer. So if something's feeding back, you'll see it. You'll see. And look, you can move these notches around and stuff. You can notch them. I don't boost anything. That's for the recorders. You're a sound guy.
I'm not a sound guy.
No. Yeah. Smart guy. Yeah.
I don't want you to think I'm more than I am, though.
There's a this board is dope. Like there's a graphic EQ available for the main. Yeah. The main has a graphic and a parametric EQ available.
Lunch and Learn is supposed to start pretty soon, right?
Lunch and Learn is officially 12:45.
So let's go ahead and now there's some talking during the Lunch and Learn stuff, right? Like there was usually. Do you not remember yesterday? Go ahead and start the records.
Well, I gave you the 411.
Hello? Hello? Hi. Good? Cool. Thank you. Hello, hello. Yeah. Hello? Is it on? Okay. Hey everybody, my name is Doug Guthrie. I'm a solutions engineer at BrainTrust. As you can see here, we're an end-to-end developer platform for building AI products. We do evals. If you watched the keynote this morning, you saw our founding engineer jumping up and down on stage yelling evals. I am not going to do that. I'm not as funny or cool as him, but we should all be very excited about evals here. Very brief agenda of what we'll cover today in this sort of this intro. Very, very brief company overview. Give you an intro to evals. Why would you even start thinking about using them? What are they? What are the different components that you need to create an eval? Some more BrainTrust specific things via running evals via our SDK. You'll see in the examples that you can run evals both in the platform itself as well as the SDK. I think it's a really kind of cool thing that we can connect maybe the local development that we're doing with what we're doing within the platform. And then how we then move to production. This is maybe human review. This is online scoring. So how well is our application performing in production? And then lastly, a little bit of human in the loop, getting user feedback from your users. How do we now take some of these production logs and feed them into the data sets that we're using in our evals, creating this really great flywheel effect. Cool, quick company overview. You see up there, maybe in the top right, some of our investors. Maybe a quick call out on the leadership side. Ankur Goyal is our CEO. Maybe the reason to call out that is Ankur, in the last two stops, he essentially built Brain Trust from scratch at the last two places, and this is really where he found the idea to like maybe this is actually a thing that people need, and really like the origination story of Brain Trust. The other thing to call out here is like we already have a lot of companies using Brain Trust in production today. This is just a few of the companies that are utilizing us for evals, for observability of their Gen AI applications. So I won't bore you too much with that, but let's jump into this. If you're at the keynote, you probably saw a similar slide here. I didn't take it out, but you see like the tech luminaries here. I think as Manu referenced them, talking about evals and the importance of them. I think this is obviously this is an intro to evals track, and what better way to start this out with some really influential people in the space talking about evals and why they are so important. So why would you think about evals, right? They help you answer questions. So here's a few of them. When I change the underlying model to my application, is it getting better or is it getting worse? When I change my prompt, right? When I change certain things about the application, is it getting better or is it getting worse? We want to get away from not having a rigorous sort of process around building with large language models, which, as you all know, right, with non-deterministic outputs creates somewhat of a challenge. And without evals in place, it becomes really, really hard to create a good application that we can put into production. Maybe some other ones, like obviously being able to detect regressions within the code. I think the other thing that Ankur mentioned to me when I first started, which I didn't really mention this, but this is my third week at Brain Trust as a solutions engineer. But one of the things that he mentioned to me that I thought really resonated was evals are a really great way. I think people think of them as almost like unit tests for our applications. But he kind of described it another way of like, this is a really great way for us to play offense as opposed to just playing defense, where I think maybe unit tests are kind of used for. This can actually be used as a tool to really help create a lot of rigor around us building and developing these applications and ensuring that we actually build things that we can put into production. Maybe from like a business perspective, why would you think about running evals or using evals? Here's a few here. If you have evals running both offline and online, you create this feedback loop or this flywheel effect. I think Manu mentioned in the keynote, excuse me. And this flywheel effect allows us to cut dev time, allows us to enhance the quality of this application that we're putting out into production. If you're able to connect the things that are happening in real life with your users in production and being able to filter those logs down, add those spans to data sets, inform what you're doing in an offline way, creates that flywheel effect that becomes really powerful from a development perspective. Again, a little bit more on the customer side. Here's a few of our customers and some of the outcomes that they've seen using Brain Trust, whether it's moving a little bit faster, pushing more AI features into production, or just increasing the quality of the applications that they have. Here's a few of the outcomes that we've seen, or that they have seen. So let's start talking a little bit about the core concepts of Brain Trust. Obviously, we're here to talk about evals. The things that I think you see, like these arrows going one way and the other. This again is that flywheel effect that I described earlier. There's the prompt engineering aspect of this. In Brain Trust, think of this playground that we have as an IDE for LLM outputs. The playgrounds allow for that rapid prototyping. As we make those changes, as we change the underlying model, what is the impact to that particular task or that application? Then those evals allow us to understand the improvement or the regression of those changes. And then the observability aspect, right? This is the logs that we're generating in production, the ability to have a human review those logs in a really easy, intuitive interface, and then have user feedback from actual users be logged into the application as well. So what is an eval? Yeah, you probably heard this several times today, throughout the week, if you stop by the booth, but sort of our definition here is that structured test that checks how well your AI system performs, right? It helps you measure these things that are important: quality, reliability, correctness. So what are the ingredients in an eval, right? I've been talking a little bit about task, right? This is the thing, the code or the prompt that we want to evaluate. The really cool thing about Brain Trust is that this can be as simple as a single prompt, or it could be this full sort of agentic workflow where we're calling out to tools. There's no sort of limit onto the complexity that we put into this task. The only thing it requires is an input and an output. The second thing is a data set. This is our real-world examples. This is essentially what we're going to run the task against to understand how well our application is performing. And how we do that is via scores. So the score is really the logic behind your evals. There's a couple different ways to think about this. There's the LLM as a judge type score. So you give it the output and some criteria, and it is able to assess, like say, I want, based on this output, is this excellent, is this fair, is this poor? And then those outputs then correspond to 0, 0.5, or 1. You also have code-based scores, right? These are maybe a little bit more heuristic or binary, but we can use both of these to really aid in the development of that eval and ensuring that we're building a really good application. I think I just sort of mentioned this here as well, but like the two mental models here of evals, there's offline and online. Offline is pre-production. This is us actually doing that iteration. It's identifying and resolving issues before deployment. This is where we're defining those tasks. It's where we're defining those scores. Online evals, this is that real-time tracing of the application in production. It's logging the model inputs and the outputs, the intermediate steps, the tool calls, everything that's happening. It allows us to diagnose performance and reliability issues, latency. Based on how you instrument your application with Brain Trust, we can pull back lots of different metrics related to cost and tokens and duration, and all of these things help inform how we build this application. I'll jump into a little bit more of like how we can instrument our app for online evals. We're going to first, I think, talk a little bit more of the offline. Before doing that, maybe just like level set on how to improve. I think one of the things that I've seen in the last few days here, the conversations that I've had, it's like almost how do I get started? Or what do I do if X? Or those types of questions. Another thing I heard from Ankur very early on is that like just get started. Create that baseline that you can then iterate and build from. I think a lot of people get caught in like creating this golden data set of test cases that they can then like iterate from. Start, you don't necessarily have to do that. Start and build that baseline. Establish that foundation that you can then improve upon. But this is a really good sort of matrix of like, if I have good output but a low score, what do I do, right? Improve your evals. If I have bad output and a high score, improve your evals or your scoring. But really good kind of like high level understanding of where to start to target your efforts when you are building these apps and you're creating evals. So let's jump into the actual components that I just talked about. So within the Brain Trust platform, we have a task. Again, this could be a prompt. This could be like this full agentic workflow. Very basic. You see that GIF running. This is a prompt within the platform. You specify an underlying model that you want it to use. You give it a system prompt. You can also give it access to tools. It has access to mustache templating, so you can pass in variables like user questions or the input from the user, its chat history or metadata, right? So when we actually go and want to parse through these logs, the metadata becomes actually beneficial, enabling us to do that in a really easy way. Going forward, maybe we have a multi-turn sort of chat type scenario where we want to add additional messages for the system and the assistant and the user and our tool calls as well. The platform allows for that just via this plus this messages button, and then you're able to add those different messages to the prompt. Also, we can add tools. So oftentimes the prompt will need access to something, right? Maybe it's a RAG type workflow, maybe it's doing web search, whatever it is, we can now use those tools as part of that prompt, right? And so when you sort of encode in that prompt, like make sure you use X tool, this prompt has access to that tool while it's running. The last one, this is actually a feature that is in beta right now. It's actually creating more of that agentic type workflow within the Brain Trust platform itself. So it's a way right now, at least, to chain together prompts where the output of one now becomes the input of the other. But if you think back maybe to this slide, if I have sort of this prompt that has access to tools, you create a pretty powerful system here where you're able to go from maybe that first step that has access to a certain tool, and we get some output from that. We can then go to that next step that has access to maybe some other tools, right? This sort of like maybe multi-agent type of workflow we can create with the underlying tools within those prompts. The second thing that I talked about is data sets, right? These are our test cases that we want to give to the task to run, so we can sort of iterate over that. We can get the output, and then going down a little bit further, actually score that. But this is obviously really important when we're running our evals, and then when we are trying to pull from production, right, the actual logs that are happening, we can add those spans, those traces, to the data sets in a really easy way, and I can show you what that looks like. But if you look there at the bottom, the only thing that's required is the input. You also have the ability to add expected. So what is the expected output for that input, right? You can sort of like create some sort of score that looks at the output with the expected. There's a score called Levenstein that allows you to measure the difference between those two. So you can do some different things based on what you provide to that data set. You also have metadata as well, again, being able to filter down different things, pulling the data set maybe into your own code base, and I want to filter by, again, X, Y, or Z via the metadata. That's all possible. I mentioned this a little bit ago, but just start small and iterate, right? You don't have to create this golden data set to get started here. Just start, and then continue to iterate and build from that baseline. The human review portion also becomes really powerful, again, when we have stuff being logged within production, having humans actually go through those logs. And there's lots of different ways to filter it down to the things that they should be looking at. And then we can now decide to add those things to certain data sets that then inform the offline evals that we're running. The last ingredient here that we need for our, for our evals are our scores. We have both code-based scores, right? Again, this is like more of those binary type conditions, but you can actually code TypeScript or Python. You can do that within the UI, as you see over there on the bottom left, or you can, within your own code base, create that score and then push it into Brain Trust so we can use it in the platform. Other users who maybe aren't in the code base can use that score as well. The other score that we have access to is called LLM as a judge. So this allows us to use an LLM to sort of judge the output. We can give it the set of criteria that indicates what a good or a fair or a bad score, or whatever it is. You get to decide what that looks like. So you give it that criteria, and it says, if it's good, I want to do a 1. If it's bad, I want to do a 0. But this starts to create the scores that we can use in that offline and that online sense. The other thing to call out here is that we have internally built a package called auto evals. So this is something that you can now pull into your project. These are out-of-the-box scores that are both LLM as a judge as well as code-based. And so it just allows you to get started very, very quickly. Another thing I heard Ankur mention is maybe starting with Levenstein, maybe not the best score in a lot of cases, but again, it establishes a baseline. Very, very little development work for our users, but it creates that thing that we can then build from. And now you have a direction to go in, to go build maybe that more custom score. Some of the things that we've heard from our customers, some tips that, important to think about. A lot of our customers are using higher quality models for scoring, even if the prompt uses a cheaper model. Just makes a lot of sense, like while we're running that application, to use the cheaper model, but use the more expensive one to actually go out and score it. Also break your scoring into very focused areas. So the example that I'll show is an application that generates a change log from a series of commits. So I could create a score that says assess my accuracy, my formatting, and my correctness. Or I could create 3 different scores that assess accuracy, and then formatting, and then correctness. So have your scores be very targeted to the thing that they're supposed to be doing. Test your score prompts in the playground before use. And then avoid overloading the score or prompt with context. Focus it on the relevant input and the output. A couple things here. Here's where, over on the left, we have our playgrounds. This is where we do that sort of like rapid iteration, where we can pull in those prompts, we can pull in those agents, add our data sets and add our scores, and we can click run, and it'll go out and sort of churn through that data set that we've defined, and will give you a sense for how well your task is performing against the data set with the scores that we define. But this is the place where developers, PMs, we even have a healthcare company that has doctors coming into the platform and interacting with the playground and even doing human review as well. Depends a little bit, obviously, on the organization. The thing on the right is our experiments. This is our sort of like snapshot in time of those evals. So imagine now, like as we are doing this development and we're trying to understand, like the last month or so, are we getting better, right? The changes that we are making, the model changes, whatever it is, are we improving our application? And the experiments is a really great way to understand that. Really important maybe to call out as well, you can see in the bottom right, the evals can happen from the application, right, the Brain Trust platform, as well as via the SDK. Cool. Maybe just really quick, because nobody likes looking at slides all the time. I certainly don't. Maybe if you haven't seen Brain Trust yet, this is maybe a good quick demo. So again, like the idea here is I have this application. I'll show you over here. You give it a GitHub repository URL. It grabs the most recent commits and then creates a change log from there. And then once this completes, you can even provide some user feedback. But this is the thing that we want to evaluate. So what I can do, I'll go into my playground, right? This is the place where I can start to run those experiments, or I can start to iterate on that prompt that I have. From my project, I've actually loaded in two different prompts. So maybe before going into the playground, I've actually created these 2 prompts within my code base, and I've pushed them into the Brain Trust platform. I've also created a data set in that code base, and I've also created some scores, right? These are the ingredients that we need to run our evals. So now when we have those different components, now we're able to start to iterate here. So I'm gonna actually create a net new playground, and I will load in one of these prompts. So again, here's my first prompt. My first prompt has a model associated with it. What becomes really cool here is the ability to iterate on the underlying model, right? I think a lot of us we have access to a lot of underlying providers, and we want to be able to understand if I change this, or if a provider adds a new model, what is the impact to my application? So I can duplicate this prompt and maybe change this to GPT-4.1. I can run this. Before I run it, I have to add all of my components. So I'll add my data set, and then I can add my different scores that I've configured here for my change log. And so I can click run, and then now we'll understand here what is the effect of changing the model for this particular task with the scores that I've configured against this data set. So this will churn through all of these in parallel, and we'll start to get some results back. Lots of different ways to actually start to look at this data. I always like coming over to the summary layout because I can understand, like, you can see over here, this is my base task right here, and then my comparison task. So I can understand, looks like, on average, the base is performing a little bit better than my comparison task on my completeness score. It's faring a little bit worse on my accuracy score. Both of them are 0% on my formatting, so probably have some work to do there. But you can start to see how you can use this type of interface to iterate very quickly. Right now, the other thing that maybe shouldn't do, but I can't resist because we just released this today, is this new loop feature. So imagine you're a user within BrainTrust. And before this, you would sort of manually iterate here, creating net new prompts, making modifications, changing the model. What if you could now utilize AI to go and do that for you? So any sort of like cursor-like interface, we can ask it to optimize a prompt. And I think the really unique thing here is it has access to those evaluation results. And so when it goes to change that prompt, it understands that it changes the prompt, it runs the evaluation, it understands if it got better relative to the scores that we defined. So you can see it's going to go through here. It'll fetch some eval results. You'll probably see a diff here very, very soon. If we don't, I won't hang out here too long, but I do want to highlight one of the things that we are releasing that really enables our users to iterate in a really, really fast way. So here's my change. We can click accept, and then it'll actually go out and run that eval again, or it would. I think I have an issue with my Anthropic API keys. But the idea here, again, is like we can create that very rapid iterative feedback loop here within the playground. The other thing here is we can run these as experiments. So this is where we can start to create those snapshots in time of that eval. And again, see as I make these changes to that application, how is it sort of performed over time? I want to make sure I don't want to go down. I don't want to decrease the performance of my scores relative to obviously the last time it ran, but looking out over the last month, 6 months, whatever it is that we're tracking. Cool. So that was very, very brief sort of intro to like evals via the UI, right? Again, like just to summarize, we need a task, we need a data set, and we need at least one score. We can pull those into the playground, and now we can start to iterate. We can save these via experiments, and now we have a way in which we can understand how well this application is performing, right? This is no longer like qualitative, right? This isn't like, hey, I think this got better, that output looks better. There is actual rigor behind this now. Customers oftentimes ask, though, like, I don't really want to use, or I'm not going to use the platform as much. I'd rather use this from my code base. Is that possible? And it is. We have a Python SDK. We have a TypeScript SDK. There's some other ones as well, Go, Java, Kotlin. For the most part, most of our users are using Python or TypeScript. Here's just a couple examples of what this might look like from an SDK perspective. Actually, if you all aren't opposed to looking at some code, here's just a really basic example of defining a prompt within my code base and then pushing it into BrainTrust. So just leveraging that Python SDK. Another example, I should come over here, creating a score. So you give it sort of like the things that it's looking for, but now I've sort of defined this score within my code base. It's version controlled. Also, the prompts that you create within the UI are version controlled as well. But this is just another way to start to interact with BrainTrust. So again, scores, we could do data sets, and then you can even do prompts up here as well, I believe. So here's my eval data set. Here's my changelog to prompt. Again, being able to start from the code base and actually push them into the platform is possible. Just depends on the organization where they want to start. The other thing here is like this is more on the components of the eval side. So that's that top portion. Define those assets in code, run that BrainTrust push, and now you have access to that in that BrainTrust library. The other one is actually like defining the evals in code, right? So what that looks like is slightly different. Come over here. So we have our eval. This is just a class that's coming from our BrainTrust SDK. Again, it's looking for the exact same things that I just described, right? A data set that we can use from BrainTrust itself, the task that we want to invoke, and then the scores. So again, defining this here within your code base, certainly possible, and then I can run a command that actually runs that eval within BrainTrust. So from here, go into BrainTrust, see the eval running. This is now experiment that I can view over time. So again, like you saw two different types of workflows here. Again, catering to maybe 2 different personas, or again, the way in which organizations want to work, it's up to them. Brain Trust is very flexible in how we allow our users to consume or use the platform. Probably jumped ahead a little bit, but this is sort of a recap of what I just showed you. Again, from your code, you create your prompts, your scores, your data sets. You can push them in there. Maybe just important to highlight here of like why you would do this. You want to source control your prompts. The big one here to call out is the online scoring. I have a section in a little bit, diving a little bit deeper into that. But if you want to use those scores that we define in the data set, we should push them into Brain Trust so that we can create online scores. We can understand how our application is performing in production relative to those scores that we want or that we're using within our offline evals. What I just showed you, maybe another variation of that eval within our code, again, defining that data set, defining that task, defining those scores, becomes very, very easy to now connect these 2 things. It's just, again, up to you to decide where you want to do this. The other thing to call out here is that this can be run via CI/CD. We do have some customers that want to run their evals as part of the CI process, so understanding in a more automated way, right, the score for A, B, and C, whatever they've configured. Has it gotten better? Has it gotten worse? This becomes maybe a check as part of CI. There is, if you look within our documentation, there's a GitHub action example that shows you how you could set this up. Cool, let's move to production. Moving to production entails setting up logging, right? It entails instrumenting our application with Brain Trust code. Being able to like say, I want to wrap this LLM client, I want to wrap this particular function when it goes to call that tool. It becomes very, very easy to do that. But so why should you do it? I think I've probably said it numerous times here, but we want to measure quality on live traffic. Right? We actually want to understand how well our application is performing with those scores. Really great to use during offline evals. It becomes our aid in ensuring that we build really good applications, that we're not creating regressions, but also really important to monitor that live traffic. The other really important thing to call out, I think, is that flywheel effect that it creates. So we have these data sets that we use to inform our offline evals. It's very, very easy now to take the logs that are generated within production and add those back to data sets. This also speaks to some of that human review component, where we want to now bring those humans in. They can start to review some of the logs that are relevant, like maybe there's user feedback equals 0, maybe there's a comment or whatever it is, but like they can filter down to those particular things. And as they find really interesting maybe test cases, it's very, very easy to add those back to the data set that we use in our offline evals. So I think the feedback loop or the flywheel effect that this creates is one of the really fundamental value props of the platform. So how do we do this? There's a couple different ways. Right? We're first going to initialize a logger. This is just going to authenticate us into Brain Trust and point us to a project. You may have seen when I opened up the platform, I had numerous projects inside of there. You can almost think of a project as a container for that feature. Right? So you probably have multiple AI features that you're building. I want to have a container for feature A, for those prompts, those scores, those data sets. You could certainly utilize those things across projects, but it becomes a really good sort of way to containerize the things that are important for that feature. Then you can start really basic, right? You can wrap an LLM client. So when you saw some of those metrics with like tokens and duration and costs, just very basically within the script, or excuse me, the code here, I just wrapped that OpenAI client, and now I'm just sort of ingesting all of those metrics into my logs. That's the easiest way to get started. You obviously probably want to do a little bit more. Again, maybe you want to understand when that LLM invokes a tool. So I want to trace, I can add a trace decorator on top of a function. I can even use some of the Brain Trust low-level span elements to create custom logs. And I want to customize the input, and I want to customize the output and the metadata that we log to that span. So again, you can start very basic with wrapping in a client, and then go down to the individual span itself, specifying that input and that output. This leads us to online scoring. Right? I talked a little bit about this. Right? This is where when our logs are coming in, we can actually configure within the platform those scores that we want to run, and we can specify sort of a sampling rate, so we don't necessarily run that score across every single log that comes in. Maybe it's 10%, 20%, so on. But it creates that really tight feedback loop that I've been talking about. Also, maybe just important to mention, the early regression alerts. So we can create automations within the BrainTrust platform. If my score drops below a certain threshold, let's create an alert with our automation feature. This is just, and I can maybe walk through what this looks like instead of showing you here. The custom views, this is where there's a lot of really rich information within these logs. And it becomes really important, I think, again, for the human review component to filter these down to the things that they care about or the things that anybody cares about. So we can create custom views within BrainTrust with the appropriate filters. And then it's very easy for that human to go into what we call human review mode within BrainTrust and sort of parse through those logs, the ones that are going to be most meaningful to them. Let me connect some of those dots there. So again, showing you some code, maybe good, maybe bad, but I'm guessing there's some technical people in the room that don't mind here. So if I look for you may have seen in one of those slides, there is the Vercel AI SDK. I want to wrap this AI SDK model. Again, this allows us to just create all of those metrics within BrainTrust with just zero lift from us as a developer. This becomes really easy to do. You can also see where I have specified that span itself, right? I actually want to define the inputs and the outputs of that. The reason you would do that is because you have a specific data set with a structure that you want to ensure maps to that. So when you are within those logs parsing through them, it becomes really easy to add those spans back to that data set. So ensuring that that data structure is sort of consistent across offline and online becomes really important, again, to create that feedback loop. So this is very high level of how we can start to create those spans. Now that we do, right, we can now go in the platform and start to configure our online scoring. So this is here just within this configuration pane. I can click online scoring. I'll just I'll create a new rule. So my new rule. And here's where we can add different scores, right? Obviously, I have a few here that I've been using for the offline evals. I don't necessarily need to select all of them, but I certainly can. And then I want to apply a sampling rate. So I want to actually give you an example of what this looks like, so I'm going to do 100%. The other thing to call out here is that you can apply these to the individual spans themselves and not the entire root span. So where this becomes beneficial is when you are invoking maybe tool calls. You're invoking a RAG workflow, and you actually want to create a score on whether or not the thing that it gave back is actually relevant to the user's query. So we can actually create a score specifically for that and highlight what that span is here. So again, very, very flexible in how you apply these scores to the things that are happening online. Now when I come back here to the application, and we'll just run this again, creating that change log, you'll now start to see here within the logs, this will start to show up, and then you'll start to see these scores be generated. Right? Again, this is where you can now start to understand over time in production, how are these things doing? How are they faring? Where can we get better? Again, now we can connect, again, the things that are happening in our offline evals with the things that are happening with online. The other thing to call out here is the feedback mechanism, right? We certainly have the ability to do human review, but oftentimes you want your users to provide feedback as well. And so this is just a basic example of a thumbs up, thumbs down, and you can even provide a comment here. This can now be logged to BrainTrust. So I should see over here my user feedback. So here's my comment, and then I have my user feedback score. But now I can also do something like this. So again, maybe I want to filter my logs down to where user feedback is 0. So click that button. I'm going to change this to 0. Right, I don't have any rows yet like that, but now I can save this as a view, and people who are now using this as human review can filter this down to where user feedback equals 0, and we can figure out what's going on, right? What are the things that fell down here within this application that we need to go fix? The other thing I'll highlight here is our sort of human review component. You click that button, or you can hit just R, and it opens up this different pane of your log. So it's a pared down version of what you just saw there. It's a little bit easier for a human to go through and actually look at that input and that output. But you, as a user of BrainTrust, can configure the human review scores that you would like to use. So I have this add something here, so maybe this is a little bit more free text. I have a better score. Again, these are the things that you can add to your platform that map to the scores that you want your humans to add to those logs. Just really quick, I'll highlight some of these things here. This is what it starts to look like when you instrument your application with those different wrappers or those different trace functions. I'm able to understand at a very granular level, the things that it's doing, right? So I essentially have these tool calls where it's going out and it's grabbing the commits from GitHub. It's understanding what the latest release is, and it's fetching the commits from that latest release, and now I can generate that change log. But again, the really unique thing here, and maybe a different example of this, is I can start to score those individual things that are happening. So this is a different application with this example. So if I open this up, I have this conversational analytics application. So a user can ask a question, it can return back some data. But this application goes through these various steps. Like the first step is to rephrase the question that the user asked. So imagine like there's this chat history that we can load in as input, and the LLM needs to rephrase that user question. If the LLM does a really bad job of rephrasing this question, everything as a result of this will fall down. Probably not going to get a right answer. So what I can do is create a score specifically for that span to understand how well the LLM did in rephrasing that question. I can also understand the intent that I was able to derive, or the LLM was able to derive from that question. Is that right? But you start to think of like these more complex type of applications that you build. You need to be able to understand the individual steps that are happening, and BrainTrust allows for that very, very easily via these scores, and then being able to apply them not only, again, while you're in offline eval kind of mode, but also online, right? We want to understand these logs and be able to apply these scores at the individual span level. This becomes pretty powerful as well. I think I actually stole from my next section, my human in the loop. Kind of walked through this a little bit. Maybe just another call out. If you happen to be at one of our workshops on Tuesday, Sarah from Notion, who's a BrainTrust customer, talked a little bit about how they think about human in the loop. And I think it's important to consider like the size of her organization and what they're doing. She mentioned that like she has a special type of role that they use for human in the loop type of interaction, right? It's almost like a product manager mixed with an LLM specialist. They're the people that are going through and doing those human reviews. Smaller organizations, she made a comment that it actually makes a lot of sense for the engineers, some engineers to actually go through and do this as well. Becomes really powerful to pair like the automation with the human component of this. Like this is not going to go away. I think it adds value to the process. Again, I think I just stole for myself like why this matters, right? This is really critical for the quality and the reliability of your application. It provides that ground truth for what you're doing. Two types of human in the loop interactions here. I walked you through that human review. Give me 1 second, and I'll call you. Yeah. The two types, the human review, being able to like create that interface within BrainTrust that allows that user to kind of parse through the logs in a really easy manner, as well as configuring scores that allow them to add the relevant scores to that particular log. And then the user feedback. This is actually coming from our users in the application. Again, being able to create sort of views on top of that feedback that then power maybe the human review and then creates that flywheel effect that we want. That's all I have today. Appreciate you all coming out here and listening to me. But yeah, you had a question. Thanks. Yeah, the question is around like how are we using human review and like some of the logs and informing the offline eval portion of this, largely that? Cool. Yeah, one thing maybe I didn't highlight here is, so maybe back within Brain Trust, I'm going to go back to my initial project. So imagine now like we have all of these logs. We filtered it down to a particular, oh. Are we still showing? On the screen? Awesome, thank you. Yeah, so imagine like we have this, this process now, right, where we're doing that human review. We filtered it down to the records that are meaningful for whatever reason. It becomes really easy, again, to connect what's happening within production. So maybe I select all of these rows, or I select individual rows, but I can add these back to the data set that we're using within those offline evals. I think I've said this like 100 times over this conference, this flywheel effect. This is like, I think, what's missing oftentimes when we're building these AI applications and what Brain Trust allows for really seamlessly. Yeah.
I have two questions. The first one is about production. Is it possible to have multiple models in production and compare how they behave?
Yeah, I don't see why not. Like my guess is in the underlying application, you're swapping them out.
Like having like A/B tests, you know, I can have like 2 or 3 or 4 and easily compare.
Absolutely, yeah. Let's see if I have an example here. You're able to group some of these scores. Maybe this is sort of an example of what you're talking about. So like maybe within production, we have different models running. This sort of view here allows us to understand like the models that we're using under the hood. And this is just, you know, you could do this within production as well and sort of do that A/B testing.
Cool. My second question is about humans in the loop, right? Let's suppose that I have multiple humans and they behave slightly different as scorers. Do you have anything, or what is the vision to do with that? Like, is there a way that I can actually compare how they're scoring or something like that, or not really?
So different users can maybe have different sort of criteria for scoring. Maybe the first thing I would say to that is like there should be like maybe a rubric for your users who are interacting with human review. So you're not creating that. You certainly have the ability to see like who is scoring different things within the platform. I'm not sure if you're able to pull that as like a data set to like assess the differences there, but maybe like before it gets to that place, like have a rubric, have a guideline of what scoring looks like for your humans.
Okay,
Yeah.
thank you.
Yeah, of course.
Hi, so the scorers I'm used to working with for like LLM as a judge are like, they're relativistic, right? So they can't tell you, is the answer relevancy good or bad for a single run, but it can tell you how it compares to previous iteration of like the same test set, for example. Do you guys use LLM as a judge scorers for online, or how are they relativistic like that, or do you have some way to be like, this is a good answer, you know, in and of itself for this sample, or because it's all, you have new data coming in, right?
Yeah, I think a lot of our customers who are thinking about this are like almost doing evals on their evals, like trying to understand, did the LLM as a judge actually do a good job there? So like when that actually runs, there's a rationale behind it. And so you can sort of run an eval of those LLMs as a judge. I think Sarah from Notion in our workshop described sort of a process like that within Notion, but I think that's sort of like where I would aim you.
Okay.
Yeah.
Cool. Thanks.
Cool. Awesome.
Are any of your customers doing evals before they launch? Like, I'm working with a government. They don't want to launch until we show some accuracy levels.
Yeah.
So we're getting our subject matter experts to enter in all the questions that they have, right? And they have huge data sets of thousands of questions, believe me, as a government. And then we're using measures like you're talking about. Do you have a way to do that? Like, I guess it's the same, is it?
So what you're describing is what we call offline evals, right? This is development.
Right.
We can actually do this testing before we get into production. This is what I was talking about, like establish that baseline,
right,
using those scores, using that data set that you've already created. But this all happens before we get into production, right? And then you can, like, one of the things that I heard from somebody earlier is like, one of my challenging things of building this AI application is establishing trust or creating that trust in this thing. That's part of what this is, right? It's like it's showing those people the scores of that application. So you start to iterate on this thing. Maybe it starts at 20%, then it goes to 30, then at 40, and so on. That to me is the thing that you use to create that trust and create that like groundswell to push it into production.
Okay, yeah, that is what we're trying to do.
Yeah.
So, but I wondered if I can see the tool does that. Thank you.
Yeah, of course. Yeah. Time for one more.
Thanks. Quick question. I love the CI/CD components. We're trying to build a lot. We're trying to build like ML as a platform for our team. So we can get into evals and stuff like that. So how much of the monitoring dashboard you have in BrainTrust can actually be like take the data taken out and post it in a unified dashboard somewhere else?
Yeah, all of this is available via SDK, right? You can pull down experiments, you can pull down data sets. So you're able to, pull this down. Like we have a customer that is actually building their own UI on top of like the SDK itself. Like, so they built their own sort of like components utilizing the SDK and pulling the sort of things that we've logged, the experiments that we have in the application into their own UI. So certainly possible.
Oh, great,
yeah.
Thanks.
All right, cool. Thanks, everybody.
Woo!
Check, check, check.
Hey, nice job. Good to see you. Not too bad. It was tolerable.
Hi, we need to get you set up for your...
Okay, great. It's time. Yeah.
Okay, so a couple of tips on your video engineer if you want.
Testing 1, 2, 3.
Awesome. So make sure you have no copyrighted material in your slides because it is being streamed on YouTube and they're very aggressive about it. A couple people had a slide that was a stock photo, but it's still.
I don't think we have any stock photos.
Oh, no, great. Are you both speaking?
He's speaking. I'm the handler.
Oh, okay, great. The other thing is because we are streaming, I have to, it's mostly a slide and then I have almost like extreme close-up of you, so hang around the podium.
I will.
You know, some people like to pace.
No, I don't like to pace.
With the camera, but what happens is it looks like this.
I'm just going to put my backpack over here.
Yeah, or over there.
Perfect, yeah. I'm not cool enough to pace.
And we also started in that time. We have a total of 20.
Perfect.
Right? That's out of respect for the next speakers that are back. Right? Awesome. And then includes the Q&A.
Excellent. I don't think there's any Q&A. We'll see.
We'll see. And if somebody does shout something from the audience, because people do, just incorporate the question in your answer, please. Because somebody on the stream might have the same question. Okay? Cool.
You Ankur?
Yeah.
I'm John.
Hey.
Good to meet you.
Good to meet you.
Brent Trust as well?
Yes.
Cool. Let's make sure your computer's working up.
Okay.
Come up here. And I do have a hard line for the internet.
Great. I don't think I need any internet.
Sorry, and then there's where'd my HDMI go? How do you keep doing that? Like that. Let me just get that. There you go.
Let me hide some windows before it resizes again. It's not sharing right now, is it?
No, it's not.
Okay. I just want to hide.
No, I have that. It's my holding slide.
Perfect.
Okay. And it might ask you to use the mirror. I'm just
What's up, Alan? Hey. Thank you. Oh, hey. I saw Sydney yesterday, or the day before. Yeah.
That was a dude from the brotherly thing, you know. All right, so you want to hide.
How's the conference been for you guys so far?
Cool. And I'm going to turn this off
Nice.
basically right now, right?
No,
Or you'll do
it's
it.
locked. I've got control.
Great.
Just
Nice.
Slip it in the pocket?
Yeah, put it in your pocket and try to hide it.
Oh, yeah, yeah.
Yeah, cool.
All right.
It's like the guys on TV. It's all you see is the microphone.
Like this. Mr. President, get down here. Thank you.
Oh, you guys are doing an event tonight?
Hello, hello, hello.
Hello. Cool. Okay. Is it related to the conference? Oh, okay, okay. Nice. Oh, I'm on now. Well, oh, okay. 1 sec. Whatever. Okay. I'll stop the small talk. So how many people saw Manu's keynote? Nice. I'm Manu's less cool brother. Awesome.
All right. Welcome, y'all. Welcome again to the second part of the track for the eval here at the AI Engineering World's Fair conference. We're doing something interesting in this room where I've actually asked the AI to write up the introduction for our speakers. So without further ado, I've asked Gemini 2.5 Flash preview to introduce Ankur Goyal here. It's saying that please welcome the CEO of BrainTrust, drawing from his extensive experience, including leading the product for Google Cloud AI platform. I don't think that's true. So Ankur is here to share invaluable lessons from the eval frontlines for every AI engineer. So without further ado, Ankur Goyal.
Thank you, Gemini. Awesome. Really excited to share some stuff with you all today. And I'm going to talk about 5 hard-earned lessons that we've learned over the last year or so about evals. So first, just a little bit about us and where we learned some of these lessons. At BrainTrust, we build a product that helps people do evals and observability. We work with some really great companies that are building products in the space. And we pulled up some stats. I find some of these numbers kind of interesting. Across all of our users, and this includes like free users who just sign up to use our free product, the average org runs almost 13 evals a day. I think that's pretty cool. It's really what our product is about, but it's great to see just how much people are evaluating stuff. Some of the most advanced organizations that we work with are actually running more than 3,000 evals a day. So they're really testing and experimenting with quite a bit. And some of the users who are deepest into evaluation are spending around 2 hours a day poking around their data, understanding what's working, what's not working, and iterating on it. And I think that just speaks to how much impact evaluation can have when you really take it seriously and build it into your core software engineering process. So with that said, let's talk about some of the interesting things we've learned over time. So the first thing is, I think it's super important for you to understand and define whether evals are actually providing value for your organization or not. And I tried to come up with 3 signs that you should look for that are good. So the first is if a new model comes out, you should be prepared via your evals to be able to launch an update to your product within 24 hours that incorporates the new model. Sarah from Notion, she talked yesterday, she talked about this specifically, but for the past several model releases, every time something comes out, Notion's able to incorporate the new model within 24 hours. And I think that's a really good sign of success. If you can't do that, then it means that you have some work to do on your evals. Another sign of success is if a user complains about something, do you have a very clear and straightforward path to take their complaint and add it into your evals? If you do, then you have a shot at actually incorporating user feedback, pulling it into your evals, and ultimately doing it better. If you don't, then you're going to lose a lot of valuable information into the ether. So again, I think this is a really important kind of threshold or milestone to hit. And the last one, which I'm actually going to talk about a little bit more throughout the presentation, is you should really start using evals to play offense and understand which use cases you can solve and how well you can solve them before you actually ship things, not like unit tests, which allow you to just test for regressions. And so if you really adopt evals, then I think before you launch a new product, you have a really good idea of how well the product might work given what your evals say. The second lesson is that great evals, they have to be engineered. They don't just come for free with synthetic data sets and random LLM as a judge scores that you read about online. And I think there's maybe 2 ways of thinking about this. There's no data set that is perfectly aligned with reality. I think in the cases that there's like basically nothing to do, and the use cases already work, which there are a few that are kind of like that, like solving competition math problems, for example. But for most real-world use cases, any data set that you can come up with ahead of time is not going to represent what users are actually experiencing. And I think the best data sets are those that you can continuously reconcile as you actually experience what happens in reality. And doing that well requires quite a bit of engineering. Of course, brain trust can help you with that, but I think the point is you have to think about a data set as an engineering problem, not just something that's given to you. And the same is true with scorers. I think a lot of people we talk to ask, hey, what scorers does brain trust come with, and how can we use those so that we don't need to think about scoring? And we actually have a really powerful open source library called AutoEvals, but it's very open source and flexible for a reason, which is that every company that we work with that's sufficiently advanced is writing their own scoring functions and modifying them constantly. And I think one way to think about scorers is they're like a spec or like a PRD for your AI application. And if you think about them that way, one, it actually justifies making an investment in scoring beyond just using something off the shelf. And two, hopefully it's fairly obvious that if you just use an open source or generic scorer, that's a spec for someone else's project, not yours. There's been a real shift towards context in prompts that's not just the system prompt that you write. And I actually think that just traditional prompt engineering, people say this in different ways, but I think traditional prompt engineering is evolving quite a bit, and it's very important to think about context, not just a prompt. So this is an example of what kind of a modern prompt looks like for an agent. Usually you have a system prompt and then a for loop, which runs LLM calls, issues tool calls, incorporates the tool calls into the prompt, and then iterates and iterates. And I actually took a few trajectories from agents that we see in the wild and summarized these numbers. And as you can see, a vast majority of the tokens in the average prompt are not from the system prompt. And so yes, it's very important to write a good system prompt and continue to improve it. But if you're not very precise about how you define tools and how you define their outputs, then you're leaving a lot on the table. And I think one of the most important things we've learned together with some customers is that you can't just take tools as a reflection of your APIs or your product as it exists today. You have to think about tools in terms of what the LLM wants to see and how you can use exactly what you present to the LLM to make it work really well. And I think that in most projects, it's actually very disruptive when you write good tools. It's not something that's just like an API layer on top of the stuff that you already have. And the same is true with their outputs. There's one example that we worked on recently for an internal project where shifting the output of a tool from JSON to YAML actually made a significant difference. And I know that's a little bit of a meme in the AI universe, but it's just so much more token efficient and easy for an LLM to look at a YAML-shaped data while doing analysis than extremely verbose JSON. Now, if you're writing code and you're plugging something into a charting library, it makes no difference because to JavaScript, YAML and JSON are both structured data. But to an LLM, they're very different. And so I think you have to be very, very thoughtful about how you actually construct the definition of a tool and how you construct its output for the LLM to maximally benefit from it. So I think one of the most important things we've learned, and actually I would credit some of the folks at Replit for really pioneering this pattern. But every time a new model comes out, everything might change. And I think you need to engineer your product, engineer your team, engineer your mindset so that when a new model comes out, if it changes everything for you, you can jump on that opportunity and ship something that maybe wasn't possible before. And I'm going to show you some numbers for a product feature that we're actually launching, and I'm going to show you a little bit of it today. But we've had an eval for a while that tells us how well this feature might work. And we run it every few months, and you can see, it wasn't that long ago that GPT 4.0 was the best model out there. But But things have changed, and progressively, GPT-4.1 did a little bit better. 3.7 Sonnet is much better, and 4 Sonnet is actually even more remarkably better. What that's meant for us is that this feature that at 10% would really not be viable for our users to use suddenly becomes viable. And so Claude 4 Sonnet actually came out 2 weeks ago, and we're shipping the first version of this feature today, which is just 2 weeks later. But we were able to jump on that opportunity because we ran this eval, we were ready to do it, and we saw that, okay, great, we've actually finally crossed this threshold. So everyone that I personally work with or talk to, I encourage to create evals that are very, very ambitious and likely not viable with today's models, and construct them in a way that when a new model comes out, you can just plug the new model in and try it. In BrainTrust, we have this tool called the BrainTrust proxy. There's a lot of similar tools. You could use ours or you could use something else. But really the point is that you don't need to change any code to work across model providers. And so Google just launched the newest version of Gemini. Actually, Gemini 2.5 Pro 0520 scores 1% on this benchmark. So we didn't even put it on here. But maybe the thing they launched today actually does a lot better. We can find out with just a few keystrokes, maybe right after this talk. And the last thing is, it's super important if you think about optimizing your prompts to optimize the entire system. So that means thinking holistically about your AI system as the data that you use for your evals, the task, which is the prompt, the agentic system, tools, et cetera, and the scoring functions. And every time you think about making your app better, you need to think about improving this overall system. We actually ran a benchmark, which is the same benchmark that I showed previously. It auto-optimizes prompts using an LLM. And we ran it once by just giving it the prompt and saying, like, hey, please optimize the prompt. And a second time giving it the prompt, the data set, and the scores, and said, please optimize this whole system. And you can see there's a very dramatic difference. So again, something goes from unviable to viable, but it's just super important to optimize the entire system, not just the prompt. And actually, this is a new product feature that we are starting to launch today. If you're a BrainTrust user, you can go to the feature flag section of BrainTrust and turn on a new feature flag called Loop. Loop is this amazing, cool new feature that actually auto-optimizes your evals directly within BrainTrust. So you can work in our playground and give it a prompt, a data set, and some scores, and it can actually create prompts, data sets, and scores too, and just work with it. The kinds of things that we've seen work really well are optimize this prompt, or what am I missing from this data set that would be really good to test for this use case? Why is my score so low? Or why is my score so high? Can you please help me write a score that is harsher than the one that I have right now? You can also try it out with different models. So as you can see from this, we've definitely seen the best performance with Claude 4 Sonnet, and Claude 4 Opus performs a couple of percentage points better. But we encourage you to try it out with different models. You can use O3, you can use O4 Mini, you can use Gemini. Maybe you're building your own LLM or fine-tuned model, you can try that as well. And yeah, we're very excited for this. I think I'm going to talk about this a little bit later, and I'm happy to do it with some Q&A as well. But I really think that the workflow around evals is going to dramatically change now that LLMs are capable of looking at prompts and looking at data and actually making constructive improvements automatically. A lot of the manual labor that went into iterating with evals doesn't need to be there anymore. So it's really exciting. We're excited to ship this and to start to get some feedback. So just to recap, 5 lessons that I think are really important. Effective evals speak for themselves. It's important to understand whether you've kind of reached a point of eval competence in your organization or not. It's okay if you haven't. It's not easy, but it's important to be honest about that and work towards it. When you're working on evals, it's very important to engineer the entire system. So don't just think about the prompt. Don't just think about improving the prompt. Please don't just use synthetic data or Hugging Face data sets. I know they're awesome, but please use more than just that. Please don't use off-the-shelf scores only. Write your own. Think very deliberately about how you can craft the spec of what you're working on into your scoring functions. Think very carefully about context, and I think in particular, what helps me personally is to think about writing tools like I would think about writing a prompt. It's my opportunity to communicate with an LLM and set it up for success. And how I define the API interface of the tool and I define its output has a very dramatic impact on that. Make sure that you're ready for new models to come out and to just change everything. So if a new model comes out, you want to be prepared to know that immediately, ideally the day that it comes out, and also be prepared to rip out everything and replace it with a fundamentally new architecture that takes advantage of that new model. And I think part of that is obviously having the right evals. Part of it is engineering your product in a way that actually allows you to do that. And then finally, when you think about optimizing or improving your eval performance, you have to think about optimizing the whole system. The data and how you get that data, the task itself, which, the prompt, tools, et cetera, and the scoring functions. And with that, we have some time for Q&A.
Yeah, there's 2 microphones up here, one on the left side, one on the right side. Feel free to stand up and ask your questions.
Hi, this is Jyoti. One of your slides said, take feedback and turn it into an eval. Are you concerned about overfitting evals at that point where every feedback then turns into an eval?
Oh, that's a great question. Also, nice to see you. So the question was, one of the slides was about taking feedback from real data and adding it to a data set and incorporating it in an eval. Are you worried about overfitting? And I think the answer is, I'm actually way more worried about overfitting to the data set without the user's feedback than I am to adjusting the fit to incorporate the user's feedback. The most important thing about a data set is not the state of the data set at any point in time. It is how well you are equipped to reconcile the data set with the reality that you want. And I actually think one of the things that we discourage in the product, and some people complain to us about this, I get it, if you're one of those people, but we don't automatically take user feedback and add it to data sets right now. We actually want a human who has some taste and maybe can build some intuition about the problem to find the data points from users that are interesting and add them to the data set. And I think that is your opportunity as a user to apply some judgment about oh, okay, this user is trying to do something that should obviously work. It's really sad that it doesn't work in my product. Let me add it to the data set so I can make sure it does. Excuse me.
You had a slide, I think, in the tool descriptions about with some percentages on it.
Yeah,
this one. What is that?
Yeah, so we took a few agents, we have a lot of traces, and we analyzed the relative number of tokens for different message types. So the system prompt is one message type. Tool definitions are the spec of what tools the model can call. User and assistant are tokens from user and assistant, just text interactions, and then tool responses are tokens from the tool generates itself.
Oh, and this is the percentage of tokens?
Correct, and this is the relative percentage of those tokens, yeah. Yeah, so the point that we're trying to make here is that I think in modern agentic systems, tools actually very, very significantly dominate the token budget of the LLM. And I think that it's very important to think about how you define the definition of tools and how you define their outputs so that you engineer the LLM for success. Not just sort of take your GraphQL API and give it as a bunch of tool calls to the LLM.
First off, that point about the thumbs down is such a good point. I'm working with the government, and people don't like the answer they got, for example, about taxes, and they give it a thumbs down.
Yeah.
Right? So like adding that human aspect is a really good idea. We actually even added a little thing that said, the answer is right, but I just don't like it.
That's awesome.
But my question is about your point that the new model changes everything. We've updated our models several times and use Claude and OpenAI, and we haven't found huge differences, other than recently someone really cheap wanted to use 4.1 mini, and like it seemed to ignore I swear it ignored the system prompt completely.
Yeah.
But what kind of things, when you say it changes everything, can you tell me a little more about what kind of changes you're seeing?
For sure. I think the use case that we just shipped with Loop is a really good example of that. So this is a very ambitious agent. It's looking at prompts and data sets and scores and automatically optimizing the prompts based on the data sets and scores. And this is something that we wrote a benchmark for a while ago, and we ran with every consecutive model launch, and the numbers looked more like what you see for GPT-4o for a very long time. This isn't true for every benchmark. So as part of this exercise, we actually have a bunch of evals that Loop optimizes. That's our eval set. And there's some evals, like taking movie quotes and figuring out what movie they're coming from, that have worked really well since GPT 3.5. And so there's certain use cases where it just doesn't matter. There are other use cases where they're so ambitious that they just don't work today. And I think you want to create evals so that if there's something ambitious that you want to do in the future, you are very well prepared when a new model comes out to just push a button and find that out.
Okay, thank you.
So we are out of time, but I'm sure Anchor would be happy to take more questions outside as well.
For sure.
So for the interest of time, we'll call it done on that one. And yeah, if you don't mind. All right, let's hear a round of applause.
Thanks.
So while you get going, I'll introduce you. All right, so if in case people are not aware, I fed the information of the speakers to AI, and we're doing an eval on the output of the AI. So here I have GPT-4o mini, and it says, please welcome John Dickerson. It says, pronounce Dickerson. I don't know why, but okay. The CEO of Mozilla AI, exclamation point. With a rich background as a co-founder of Arthur AI, please let us know if it's true or not.
That is true.
And a former tenured professor. John is at the forefront of building an open source AI ecosystem and has extensive experience in responsible AI practices. Today, he'll share insights on the urgent need for robust AI evaluations in enterprises, drawing from a decade of experience in the field.
That's roughly right. Thank you.
All right, cool.
Thanks, everyone, for being here. I'm going to give this talk mostly from the point of view of being a co-founder and chief scientist at Arthur AI for 6 years prior to joining Mozilla AI as CEO. I do want to say Mozilla AI operates in the open source world, where we're providing open source AI tooling, and we're supporting the open source AI stack. Our end goal is to enable the open source community to be at the same table as a Sam Altman when talking about AI moving forward. So if you're interested in that, that's not what this talk is going to be about, but we can talk about that offline. This talk is going to be about 2025 finally being the year of the evals. And as was as was spoken by my introduction, I've been in this space for a very long time. Arthur AI, for example, was in, and it still is in, observability, evaluation, and security in both traditional ML and AI, and then into the deep learning revolution, and then into the Gen AI revolution, and then into the agentic revolution. And I think we're finally at the point where all of these companies are going to start seeing hockey stick growth, which is exciting. So the thesis of this talk, one thing is that I see AI ML monitoring and evaluation as two sides of the same sword or ruler, right? You can't do monitoring or observability without being able to measure, and measurement is the core functionality for evaluation. This was not top of mind, really, with the C-suite until two things happened concurrently. One is AI became a thing that people who aren't a CIO or CTO could understand. So the CEOs, the CFOs, the CISOs began to understand it basically when ChatGPT came out. And simultaneously, there was a perfectly timed budget freeze across enterprise, at least in the US, that happened due to a fear of an impending recession. So this is right before ChatGPT launched. This is like October, November, when most enterprises would set up budget for the next year. At that time, there was a freeze, except for money that could be opened up for a specific pet project. And that pet project, because CEOs and CFOs then knew about it, was Gen AI. So that happened, and then now we have the final sort of vertex on this triangle, which is going to force evaluation to be top of mind this year, which is that we have systems that are now acting for humans, acting for teams, as opposed to just providing inputs into larger systems. So these three things together are, as you saw with Brain Trust, as we're seeing at Arthur, as you're seeing with like Arise AI or Galileo, other big players in this space, we're starting to see big takeoff because of this. Cool. So right now, this is what's happening. Year of the agent, we all hear about it. We're hearing about it here at this conference. Agents are starting to make decisions and take actions, complex steps that lead toward an action, either autonomously or semi-autonomously. As a question in the last talk brought up, bringing humans into the loop is still obviously a very good idea in many systems, but we're getting closer and closer to full automation. And agentic systems are going into deployment now. Okay? And that's in enterprises, that's in SMBs, that's in pet projects, and so on. And what that means is, by that last slide, this is also the year that we need evals. Flashback to then, up to like a year ago, where every year we were asking, hey, is this the year of ML? Is this the year of evaluations? And prior to sort of these agentic systems coming out, we would have machine learning models basically spitting out numbers that would then be ingested into a more complex system, and that complexity would sort of erase the top-of-mind need to think about what's coming out of the model itself. Except for people in this audience, we know that's very important. But when it comes to decision makers, it would often get wrapped up into this sort of opaque box. And that meant that the ML part didn't really bubble up beyond like the CIO or whatever org the system was going into, which meant that typically that year was not the year for evals, because the need for evals was not obvious to the entire C-suite. Cool. So let's take a quick step back in time. Before November 30th of 2022, the ChatGPT launch, ML monitoring was certainly a thing, right? Like data science teams have long used statistical methods as part of larger systems to understand what's going on, right? This is core. Like I mentioned, though, there's a tenuous connection to sort of downstream business KPIs. And at the end of the day, that's what gets your product bought in the enterprise, is being able to make a sell about dollars saved or about dollars earned. So being able to connect machine learning, the components specifically to a downstream business KPI. There was a lot of lip service around AI ML, around the ROI, from the C-suite, including CEOs, but that was just lip service, in our experience at least. It was still basically selling into the CIO. So basically, it made it hard to sell outside of that. Now, obviously, this is a large space. This has been happening since about 2012, I would say, is when AI ML monitoring really started up, with like H2O and Algorithmia and Seldon, sort of the first generation of these companies coming around. Y Labs, Aporia, Arise, Arthur, Galileo, Fiddler, Protect AI, and so on and so on and so on. I've put the cutoff here at like mid-2022, sort of like before the Gen AI revolution happened. There have obviously been companies founded after that. We just saw Brain Trust talking as well. And then, the big players here as well, right? Snowflake, Databricks, Datadog, SageMaker, Vertex, Microsoft's products, and so on. So people have been thinking about it, but it was never the thing. Again, rarely top of mind for the CEO, the CFO, and the CISO. It's never the issue. So when we would talk to people, it's always, yes, we understand that we need this, but security is going to be a bigger issue, or latency is going to be a bigger issue, or some of these more traditional technology sort of problems are going to be the issue. It wasn't the machine learning model itself. So basically, I do a lot of due diligence for venture capitalists as well now as a multi-time founder and so on. And basically every pitch deck in this space from like the mid-2010s onward had a slide that said, this is the year that a CEO is going to get fired because of an ML-related screw-up. And to my knowledge, it just still hasn't happened. There have been some forward-thinking leaders. So I have here the annual report from Jamie Dimon, head of JPMC. This came out in April of 2022, so it covered basically JPMC up through their fiscal year in 2021. And he's talking about the spend that they have going into AI. But if you squint and you look at these numbers, they're still like comically small. So basically, one of these is in the consumer world, he makes the statement that from 2017 up through the end of 2021, they had put $100 million into AI ML, right? That's not a huge amount of money for JPMC. So keep sitting back in time, pre-ChatGPT and so on. But let's now flip to the macroeconomic side of things. So the economy started getting pretty dicey right up until about ChatGPT launched, right? So that was the end of November for ChatGPT. A lot of enterprise budgets are set in October, November for the following year. And toward mid to the end of 2022, there were very deep fears about an impending recession that didn't end up happening, but those fears basically made it so that most enterprises either froze or shrunk their IT budgets for 2023, okay? So what that meant is, were it not for particular tailwinds called ChatGPT, we probably wouldn't have seen a lot of new technology being developed in the IT departments at these large enterprises in 2023. Right? So this is sort of a bittersweet mix. I guess I just talked about a lot of this. This was sort of a bittersweet mix in the sense that it did set us up to put the Eye of Sauron on a particular specific small pet project where a small amount of budget could be applied. And that small pet project came from our friends at OpenAI launching ChatGPT right before the holiday breaks. And I'm convinced just from talking to some C-suite folks across the enterprises here in the US that basically what happened is now CEOs and CFOs and less technical in the computer science sense of the word were able to interact swiftly and easily with a single UI on the internet and get wowed by AI, right? So I was also wowed by AI. In fact, we were hosting Arthur was hosting with our Series A leaders, Index Ventures, an event at NeurIPS, the major machine learning conference, the night that ChatGPT came out, and it basically took over a bunch of nerds in a room being like, wow, this is very, very impressive. And that happened to everybody else, right? Flip back to November 30th, you can make Eminem rap like Taylor Swift. Oh, hey, isn't this funny? Oh, hey, my mom did this sort of like joke about, I want to have poetry, but in the, written in the words of a rapper or whatever. This started to happen over and over again. And what that meant is that that discretionary budget, which exists, was unlocked specifically for now the CEO's pet projects, which were called Gen AI. So 2023, we still had austerity forced on us because of those frozen budgets, or even reduced budgets. But the thing that was happening here is that now the only money going around that could be allocated was going to specifically Gen AI. And so everybody focused on this. It's a cool technology. Everybody focused on this, and the science projects started to sort of float around within enterprise. 2024, we started to see Gen AI-based applications going into production, right? Chat applications are the obvious one, internal chat applications, internal hiring tools, things like that. And that's because basically the only budget going into new projects in 2023 was going to Gen AI. And now as things go into production, primarily internally in 2024, we have the folks who tend to dress in business suits, asking questions around ROI, governance, risk, compliance, brand optics, and that kind of thing. So now we're starting to get a little bit closer to people outside of the machine learning, the data science, the computer science world, the CIO's office, caring about evaluation, right? If I need to if I need to have a quantitative estimate of risk, then I need to do evaluation. 2025, we've seen scale-ups, right? Look at the revenue numbers for any frontier model provider. Look at the revenue numbers for a lot of us in this room. Just everything is really going up right now, and that's because of usage, which is great. That also means that's a function of the C-suite basically becoming comfortable basically talking about and putting large real budget into AI, right? So 2023's IT budgets, 2024's IT budgets set for the following year, those weren't frozen, right? Those are earmarked specifically for AI applications and things along those lines. So we had science projects in 2023 go into production in 2024, and they're now shipping and scaling in 2025. And also, frankly, the technology's just gotten really amazing, right? All of us in this room are technical, but even I'm just amazed every time a new model is dropped. The community has also really gotten behind this. Open source has gotten behind this. Venture capital, big tech is writing huge checks into frontier model providers and so on. So everything is sort of coming together in 2025. And also, remember that third vertex, we have machine learning systems now moving toward autonomy. Okay? So 2025, we all hear it, it's the year of the agent. No longer is a question mark needed here. It's clearly the year of the agent. Now, quick 30-second definition of an agent, as defined in the late 50s onward. Agents need to perceive the environment, they need to learn, they need to abstract and generalize, and unlike traditional machine learning, they're going to reason and act, right? We have reasoning models out there. We have systems that are acting in virtual environments or cyber-physical environments. And what that means is you have a lot of complexity introduced into the system, and you have a lot of risk introduced into the system. And that's great for those of us in evals. So at the end of the day, the thing that really matters, like I mentioned, is connecting when you're selling any product, not just our products in this room, when you're selling any product into an enterprise or an SMB, is being able to attach your product into some sort of downstream business KPI, risk mitigation, revenue gains, losing less money, whatever. So now evaluations, you need to be able to do this because you're quantifying things, and they're finally a first-class discussion point, which is fantastic. So we have the CEO, like I mentioned, November 30th, 2022 and onward, now at least knows what the tech is. And I'm not saying they know, what attention means, right? But I am saying that they know some of the capabilities around these generative models. They know some of the capabilities around agentic and multi-agent systems, and they're comfortable, talking to experts about it, allocating budget for it, and talking to their board of directors and shareholders about it as well. We have the CFO, who, because the CEO cares about this stuff, also obviously needs to care about it, but she's going to care about the impact to the bottom line, right? That's what a CFO does. They're doing allocation, they're doing budget planning, and they're going to need to basically write some numbers into an Excel spreadsheet, and those numbers have to come from, in part, quantitative evaluation. CISOs now see this as a huge security risk and opportunity. And for those who haven't sold into enterprises before, CISOs are typically willing to write checks, smaller checks, especially for startups, more quickly and with less overhead than like a CIO would. CIOs tend to have a bigger org for one and also tend to have a lot more process. CISOs tend to be a little bit more scrappy and willing to try out tools and so on. And so this actually happened before the agentic revolution. This actually happened when Gen AI started coming up, where CISOs were like, hey, hallucination detection, prompt injection, things like that. That's firmly in the security space, which is why you've seen a lot of guardrail products, including Arthur's, including the ones that come from our competitors, going into the CISO's office and basically being able to sign a lot of deals. The CIO, poor CIO, has been on board the entire time, and they're just trying to keep the ship sailing, so that's great. They're still on board. They want to keep their job. And the CTOs now, they always want standards, right? They need to make these decisions based on numbers. Those numbers are coming in part from like OTEL standards, standards like that. And that's great, right? So I've listed a lot of the C-suite here. I haven't talked about chief strategy officers or otherwise, but like the CEO, the CFO, the CTO, the CIO, the CISO, they control a lot of budget. And now they are all willing to talk about, and they're all aligned about basically the need to understand evaluation from AI. Great, so quick remind me, you should hold me truthful here. All the evaluation companies, observability companies, monitoring companies, security companies, whatever you want to call them, have shifted into agentic and multi-agent systems monitoring. Right? The point around you should monitor the whole system. You shouldn't just monitor the one model that is being used by one particular agent. That's well taken and well understood in industry and in government, and I think that's great to have that at that top line discussion point. But keep me honest here. There was an article that came out in mid-April in The Information showing some leaked revenue numbers for a variety of startups in the evaluation space, Weights and Biases, Galileo, Braintrust, and so on, but they were lagged by about 6 months or 8 months. And just from talking to friends in the space, those numbers are no longer representative of what folks in this area are making. And so let's see what the information leaks in early 2026 about this, and maybe we'll see something like revenue no longer lags at AI evaluation startups, because this is the year for AI evaluations. Great. So I'll leave it with some time for questions. I did mention Mozilla is not firmly in the evaluation space. We do have a very nice open source, not monetized at all, what we're calling a light LLM for multi-agent systems. So if you're playing around with different multi-agent system frameworks, check out any agent. We implement a lot of them for you under a unified interface. So for people in this room, that might be a fun project to play around with. So thank you. I'll have three minutes for questions.
So, okay, thanks. Thanks, great presentation. I just have a question really about the enterprise value about most of the evaluations in Gen AI require domain expertise. So for example, if you're building a multi-agent system to do financial investment analysis, to do something called a discounted cash flow spreadsheet, is the agent doing it correctly or not? I'm just trying to understand how is that problem getting solved? Because most of them are coming from an ML background where it was structured data, but this is a lot of unstructured data, and you have to measure the quality. Like, is it acting like a human? Right?
Yeah, it's great. Actually, I have a paper in Nature Machine Intelligence talking about some of the problems that can come around when you do persona-based agents, where I say act like a farmer in Ohio in your mid-40s and so on. There's value in that, but you can't do it perfectly. And my gut reaction to this is there was a leaked spreadsheet from Mercor, which is a company that can hire in experts, showing $50 an hour, $100 an hour, $200 an hour for experts to be hired by, for example, Google, or for example, Meta, or for example, large banks, to do kind of what you're saying, which is you're going to have an expert sitting alongside the multi-agent system, basically sitting next to the intern who's going to come in and take your job in like a year or two, or change your job. Maybe take is not the right word. But they're basically doing that expensive human validation in lockstep with the multi-agent system, which, if you're going to be doing discounted cash flow analysis, right, the kind of thing where A, you can either make or lose a lot of money, and B, lose your job if you get it wrong, it's worth spending that large amount of money doing the human validation. It's a question for everyone, though, is like, what does that look like in 5 years once that data is incorporated into the systems themselves? And that can be a mode as well, right? When you talk to anyone in the eval space, like, it's the data set creation and the environment creation that matters more than anything, which is the point you're getting at as well. So if I spend a bunch of money to have a very good competitive, like, DCF environment or whatever, that can help me versus my competitors. So there is CapEx going into that. Yeah.
Thanks for the presentation. Do you have a rough maybe timeline on when you think evals will primarily be driven by maybe Gen AI or even LLMs?
Yeah, the LLM as a judge paradigm is, and I think this was talked about in the previous talk as well, we see it getting used in practice because there are issues with it, right? We have a paper in iClear from last month talking about some of the biases that LLMs as judges have versus humans, and things like conciseness or helpfulness and some of those anthropic words. But the long and short of it is that it solves the data set creation problem in some sense, in that you can ask, you give a persona to an LLM, and it is like a poor man's version of like a human doing the judging. And so we see a lot of people using that as a crutch right now. But you need to, toward the last question that was asked, you do need to make sure you're validating this and making sure that you're not going off in some weird biased direction. But we do see them in practice. That's time? Oh, happy to chat offline.
Yep. Thank you so much, John. He is available as well. Feel free to reach out to him. Up next, we have, let's use Claude for Sonnet. So that should be good, right? All right, so let's see. Yeah, I actually asked the AI to go ahead and create the introduction for everybody. So make sure to tell us if anything is hallucinated. So please welcome Jeff Huber, CEO and co-founder of Chroma, the widely adopted open source vector database that's been making waves across the tech media from TechCrunch to Forbes, ! Joining him is Jason Liu, principal at 567 Studio and a machine learning engineer who wears many hats as a consultant and educator, ready to show you how to turn your messy conversation data into actionable insights and killer evals. There you go. Pretty good?
Pretty good.
All right.
Am I on? Hello? Can you hear me? Yes. Okay. All right. Welcome, everybody. I'm Jeff Huber, the co-founder and CEO of Chroma, and I'm joined by Jason. We're going to do a two-parter here. We're really going to pack in the content. It's the last session of the day, and so we thought I'd give you a lot. Everything in this presentation today is open source and code available, so we're also not selling you any tools. And so there'll be QR codes and stuff throughout to grab the code. So let's talk about how to look at your data. All of you are AI practitioners. You're all building stuff. And these questions probably resonate quite deeply with you. What chunking strategy should I use? Is my embedding model the best embedding model for my data? And more. And our contention is that you can really only manage what you measure. Again, I think Peter Drucker is the original who coined that, so I can't take too much credit. But it certainly is still true today. So we have a very simple hypothesis here, which is you should look at your data. The goal is to say, look at your data, I think at least 15 times this presentation, so that's 2. And great measurement ultimately is what makes systematic improvement easy. And it really can be easy. It doesn't have to be super complicated. So I'm going to talk about part 1, how to look at your inputs. And then Jason's going to talk about part 2, how to look at your outputs. So let's get into it.
All right, looking at your inputs, how do you know whether or not your retrieval system is good? And how do you know how to make it better? There are a few options. There is guess and cross your fingers. That's certainly one option. Another option is to use an LLM as a judge. You're using some of these frameworks where you're checking factuality and other metrics like this, and they cost $600 and take 3 hours to run. If that is your preference, you certainly can do that. You can use public benchmarks. So you can look at things like MTEB to figure out, oh, which embedding model is the best on English. That's another option. But our contention is you should use fast evals, and I will tell you exactly what fast evals are. All right, so what is a fast eval? A fast eval is simply a set of query and document pairs. So the first step is if this query is put in, this document should come out. A set of those is called a golden data set. And then the way that you measure your system is you put all the queries in, and then you see, do those documents come out? And obviously, you can retrieve 5 or retrieve 10 or retrieve 20. It kind of depends on your application. It's very fast and very inexpensive to run. And this is very important because it enables you to run a lot of experiments quickly and cheaply. I'm sure all of you know that experimentation time and your energy to do experimentation goes down significantly when you have to click, go, and then come back 6 hours later. All of these metrics should run extremely quickly for pennies. So maybe you don't have yet, you have your documents, you have your chunks, you have your stuff in your retrieval system, but you don't have queries yet. That's OK. We found that you can actually use an LLM to write questions and write good questions. I think just doing naive, hey, LLM, write me a question for this document, not a great strategy. However, we found that you can actually teach LLMs how to write queries. These slides are getting a little bit cropped. I'm not sure why, but we'll make the most of it. To give you an example, so this is actually a example from one of the MTEB, kind of the golden data sets around embedding models with benchmark data sets. This also points to the fact that many of these benchmark data sets are overly clean, right? What is a pergola used for in a garden? And then the beginning of that sentence is a pergola in a garden, ... Real world data is never this clean. So what we did in this report, the link is in a few slides, we did a huge deep dive into how can we actually align queries that are representative of real-world queries. It's too easy to trick yourself into thinking that your system's working really well with synthetic queries that are overly specific to your data. And so what these graphs show is that we're actually able to semantically align the specificity of queries synthetically generated to real queries that users might ask of your system. So what this enables is, if a new, cool, sexy embedding model comes out and it's doing really well in the MTEB score and everybody on Twitter is talking about it, instead of just going into your code and changing it and guessing and checking and hoping that it's going to work, you now can empirically say whether it's good, better, or not for your data. And the kind of example here is quite contrived and simple, but you can actually look at the actual success rate. OK, great. These are the queries that I care about. Do I get back more documents than I did before? If so, maybe you should consider changing. Now, of course, you need to re-embed your data. That service could be more expensive. It could be slower. The API for that service could be flaky. There's a lot of considerations, obviously, when making very good engineering decisions. But clearly, the North Star of success rate of how many documents did I get from my queries, super fast and super useful, and makes your improvement of your system much more systematic and deterministic. All right, so we actually worked with Weights and Biases, looking at their chatbot, to kind of ground a lot of this work. So what you see here is, for the Weights and Biases chatbot, you can see 4 different embedding models, and you can see the recall at 10 across those 4 different embedding models. And then I'll point out that blue is ground truth. So these are actual queries that were logged in Weave and then sent over. And then there's generated. These are the ones that are synthetically generated. And what we want to see is a few things. We want to see that those are pretty close. And we want to see that they are always the same kind of in order of accuracy, right? We don't want to see any big flips between ground truth and generated. And we're really happy to see that we found that answer. Now, there are a few fun findings here, which is, and of course, they're going to get cropped out, but that's OK. Number one, the original embedding model used for this application was actually text embedding 3 small. This actually performed the worst out of all the embedding models that we evaluated, just 4 in this case. And so probably wasn't the best choice. The second one was that actually, if you look at MTEB, Gina embeddings v3 does very well in English. It's like, way better than anything else. But for this application, it didn't actually perform that well. It was actually the Voyage 3 large model which performed the best. And that was empirically determined by actually running this fast eval and looking at your data. That's number 3. All right, so if you'd like access to the full report, you can scan this QR code. It's at research.tricoma.com. There's also an adjoining video, which is kind of screenshotted here, which goes into much more detail. There are full notebooks with all the code. It's all open source. You can run it on your own data. And hopefully this is helpful for you all thinking about how, again, you can systematically and deterministically improve your retrieval systems. And with that, I'll hand it over to Jason.
Thank you. So, if you're working with some kind of system, there's always going to be the inputs that we look at. And this is what we talked about, maybe thinking about things like retrieval, how does the embeddings work. But ultimately, we also have to look at the outputs, right? And the outputs of many systems might be the outputs of a conversation that has happened, an agent execution that has happened. And the idea is that if you can look at these outputs, maybe we can do some kind of analysis that figures out, what kind of products should we build, what kind of portfolio of tools should we develop for our agents, and so forth. And so the idea is, if you have a bunch of queries that users are putting in, or even a couple of hundred of conversations, it's pretty good to just look at everything manually, right? Think very carefully about each interaction, and then only use these models when they make sense. And then oftentimes, if I say this, they can say, what if we just put everything in O3? And then here, generally only use the language models if you think you're not smarter than the language model. Then when you have a lot of users and an actual good product, you might get thousands of queries or tens of thousands of conversations. And now you run into an issue where there's too much volume to manually review. There's too much detail in the conversations, and you're not really going to be the expert that can actually figure out what is useful and what is good. And ultimately, with these long conversations with tool calls and chains and reasoning steps, these outputs are now really hard to scan and really hard to understand. But there's still a lot of value in these conversations, right? If you've used a chatbot, whether it's in Cursor or any kind of Cloud Code system, oftentimes you do say things like, try again, this is not really what I meant, be less lazy next time. It turns out a lot of the feedback you give is in those conversations, right? We could build things like feedback widgets or thumbs up or thumbs down, but a lot of the information exists in those conversations. And the frustration and the retry patterns that exist can be extracted from those conversations. And the idea is that the data really already exists in this conversation. If we think of a simple example outside in a different industry, we can imagine the analogy of marketing, right? Maybe we run our evals and the number is 0.5. I don't really know what that means. Factuality is 0.6. I don't know if that's good or bad. Is 0.5 the average? Who knows? But imagine we run a marketing campaign and our ad metric or our KPI is 0.5. There's not much we can do. But if we realize that 80% of our users are under 35 and 20% are over, and we realize that the younger audience performs well and the older audience performs poorly, what we've done is we've just drawn a line in the sand on who our users are. And now we can make a decision. Do we want to double down on marketing to a younger audience, or do we want to figure out why we aren't successfully marketing to the older population, right? Do I find more podcasts to market to? Should I run a Super Bowl ad? Now, just by drawing a line in the sand and deciding which segment to target, we can now make decisions on what to improve. Whereas just making them ads better is a sort of very generic sentiment that people can have. And so one of the best ways of doing that is effectively just extracting some kind of data out of these conversations in some structured way and just doing very traditional data analysis. And so here we have some kind of object that says, I want to extract a summary of what has happened, maybe some tool that it's used, maybe the errors that we've noticed, the conversations that happen, maybe some metric for satisfaction, maybe some metric for frustration. The idea is that we can build this portfolio of metadata that we can extract. And then what we can do is we can embed this, find clusters, identify segments, and then start testing our hypotheses. And so what we might want to do is sort of build this extraction, put it into an LLM, get this data back out, and just start doing very traditional data analysis, no different than any kind of product engineer or any kind of data scientist. And this tends to work quite well. If you look at some of the things that Anthropic Clio did, they basically found that code use was 40x more represented by Claude users than by GDP value creation. They go, okay, maybe code is like a good avenue. And obviously that's not the really case, but the idea is that by understanding how your users develop a product, you can now figure out where to invest your time. And so this is why we built a library called Cura that allows us to summarize conversations, cluster them, build hierarchies of these clusters, and ultimately allow us to compare our evals across different KPIs. Again, so now, if we have factuality is 0.6, that's really hard. But if it turns out that factuality is really low for queries that require time filters, right, or factuality is really high when queries revolve on contract search, now we know something's happening in one area, something's happening in another, and then we can make a decision on what to do and how to invest our time. And the pipeline is pretty simple. We have models to do summarization, models to do clustering, and models that do this aggregation step. And so what you might want to do is just load in some conversations. And here we've made a fake data set of fake conversations from Gemini. And the idea is that first, we can extract some kind of summary model where there's topics that we discuss, frustrations, errors, et cetera. We can then cluster them to find cohesive groups. And here we can find maybe some of the conversations are around data visualization, SEO content requests, and authentication errors. Now we get some idea of how people are using the software. And then as we group them together, we realize, OK, really there are some themes around technical support. Does the agent have tools that can do this well? Do we have tools to debug these database issues? Do we have tools to debug authentication? Do we have tools to do data visualization? That's something that's going to be very useful. And at the end of this pipeline, we're sort of presented with these printouts of clusters, right? We know what the tools are, how the chatbot is being used at a higher level, SEO content, data analysis, and at a lower level, maybe it's blog posts and marketing. And just by looking at this, we might have some hypothesis as to what kind of tools we should build, how we should develop even our marketing, or how we can think about changing our prompts. We can do a ton of these kinds of things. And this is because the ultimate goal is to understand what to do next, right? You do the segmentation to figure out what kind of new hypotheses that you can have, and then you can make these targeted investments within these certain segments. If it turns out that 80% of the conversations that I'm having with the chatbot is around SEO optimization, maybe I should have some integrations that do that. Maybe I should reevaluate the prompts or have other workflows to make that use case more powerful for them. And again, the goal really is to just make a portfolio of tools, of metadata filters, of data sources that allows the agent to do its job. And oftentimes, the solution isn't really making the AI better. It's really just providing the right infrastructure, right? A lot of times, if you find that a lot of queries use time filters and you just didn't add a time filter, that can probably improve your evals by quite a bit, right? We have situations where we wanted to figure out if contracts were signed, and if we just extracted one more step in the OCR process, now we can do this large-scale filters and figure out what data exists. And generally, the practice of improving your applications is pretty straightforward, right? We all know to define evals, but not everyone that I work with has really been thinking about something like finding clusters and comparing KPIs across clusters. But once you do, then you can start making decisions on what to build, what to fix, and what to ignore. Maybe you have a two-set of quadrants, right? Maybe we have low usage and high usage, and you have high-performing evals and low-performing evals, right? If a large portion of your population are using tools that you are bad at, that is clearly the thing you have to fix. But if a large proportion of people are using tools that you're good at, that's totally fine. If a small proportion of people use something that do something that you're good at, maybe there's some product changes you didn't make. Maybe it's about educating the user. Maybe it's adding some pre-filler or automated questions to show them that we can do these kind of capabilities. And if there are things that nobody does, but when we do them, they're bad, maybe that's a one-line change in the prompt that says, sorry, I can't help you, go talk to your manager, right? These are now decisions that we can make just by looking at what proportion of our conversations are of a certain category and whether or not we can do well in that category. And as you understand this, then you can go out, you can build these classifiers to identify these specific intents. Maybe you build routers, maybe you build more tools. And then you can start doing things like monitoring and having the ability to do these group bys, right? So now you have different categories of query types over time, and you can just see what the performance looks like, right? Where 0.5 doesn't really mean anything, but whether or not a metric changes over time across a certain category can determine a lot about how your product is being used. By doing this, we figured out that some customers, when we onboard them, they use our applications very differently than our historical customers, and we can now then make other investments in how to improve these systems. And ultimately, the goal is to create a data-driven way of defining the product roadmap. Oftentimes, it is research that leads to better products now, rather than products justifying some research that we don't know is possible. And again, the real marker of progress is your ability to have a high-quality hypothesis and your ability to test a lot of these hypotheses. And if you segment, you can make clearer hypotheses. If you use faster evals, you can run more experiments. And by having this continuous feedback through monitoring, this is how you actually build a product, right? This is, regardless of being an AI product, this is just how you build a product. And so if you look at the takeaways, really, when you think about measuring the inputs, we really want to think about not using public benchmarks, building evals on your data, and focusing first on retrieval, because that is the only thing a LLM improvement won't fix, right? If the retrieval is bad, the LLM will still get better over time, but you need to earn the right to sort of tinker with the LLM by having good retrieval. And then lastly, if you don't have any customers or any users, you can start thinking about synthetic data as a way of augmenting that. And once you have users, look at your data as well. Look at the outputs, right? Extract structure from these conversations. Understand, how many conversations are happening, how often are tools being misused, what are the errors, and how are people frustrated. And by doing that, you can do this population-level data analysis, find these similar clusters, and have some kind of impact-weighted understanding of what the tools are. Right? It's one thing to say, maybe we should build more tools for data visualization. It's another thing to say, hey, boss, 40% of our conversations are around data visualization, and the code engine or the code execution can't really do that well. Maybe we should build 2 more tools for plotting and then see if that's worth it. And you can justify that because we know there's a 40% of the population is using data visualization, and we do that maybe only 10% of the time. Right? This is impact weighted. And ultimately, as you compare these KPIs across these clusters, you can just make better decisions across your entire product development process. So again, start small, look for structure, understand that structure, and start comparing your KPIs. And once you can do that, you can make decisions on what to fix, what to build, and what to ignore. If you want to find more resources, feel free to check out these QR codes. The first one is to Chroma Cloud to understand a little bit more about their research. And the second one is actually a set of notebooks that we've built out that go through this process. So we load the weights and biases conversations, we do this cluster analysis, and we show you how we can use that to make better product decisions. So there's 3 Jupyter notebooks in that repo. Check them out on your own time. And thank you for listening.
We do have time for like one quick question, and of course as well outside as well.
Perfect.
So
thank you.
If anybody wants to grab the mic there and over there.
Yep.
You're famous for spicy cake. What's the spicy take today? It's not KPI, by the way. That's not the spicy take.
I think more agent businesses should try to price their services on the work done than the tokens used. Yeah. Price on success, price on value. Very unrelated to this talk, but
All right. Well, if there's no other questions, definitely meet up with them for any other questions you may have. But yeah, thank you so much for coming to the eval track. Hopefully you all are sold and you're gonna look into evals and into your data as well. So thank you so much.
Nailed it at 13 seconds.
You too. Hi. Sure. Yeah. Is there a reason that the technique that I talked about using fast evals, query and document out, couldn't be for images as well, right? So yeah, I think it'll work sort of just the same. You just sort of need a labeled pair, right, of like this input should yield this output, and it could be multimodal or anything.
Realizing that that's been a complete waste of time.
Actually, which layer are you on? Like you're not dealing
It has
with any
no
data
relationship.
For Chroma or for the talk?
Actually, I already forgot there are too many contexts.
That's okay.
I guess either Chroma or the later part.
Yeah, Chroma is a retrieval system, so Chroma does like vector search, full text search, metadata search, but the talk was in some ways separate from what Chroma does commercially. Like this is just an open source set of Jupyter notebooks that show you how to like set up and run benchmarks.
Okay, so I guess neither of these deal with actual.
Not really.
Okay. Yeah, makes sense.
Yeah. Obviously, once you figure out it works for you.
There's a certain angle on the world that you get from this. It's like
Yeah. I'm not touching anything in case they come over in 5 minutes and be like, "Oh, we have a pop-up."
Yeah, right.
I don't trust it.
Right.
So don't. I'm just saying to you, don't just break
I'm not
down
going
your.
to start taking batteries out.
Yeah. I think that's also why they said don't do anything in those rooms.
Yeah.
Golden Gate A and B.
They just wanted us to hang on and see what happens.
Well, because they might just be like, "Hey, we need to do this real quick." So
Right.
it's fine. It's your problem.
Right.
I think that's why. Can you go grab the Q&A mics and the mic stands? Yeah. And bring them back here? You just bring.
So, check. I don't even need for this to be open to send it to record, okay? I wonder if I just cut it, just mute in the, nope,